So we are starting with the organic chemistry. Definitions and all will not go through. Whichever important definitions are there, I will tell you. You just have to note them down. Means these are the important definitions. Then you have to practice them. Okay. We know that organic chemistry means organic compounds must have carbon, and hydrocarbons are those which will have carbon as well as hydrogen only, right? So there are some exceptions. The compounds which contain carbon but they are not organic. So the examples are here: carbon monoxide, carbon dioxide, the metal cyanides, for example, sodium cyanide, potassium cyanide, etc. Metal carbide, you know, calcium carbide to prepare ethine, we use it. That is also ionic. They are not organic, means they are inorganic. Inorganic means they are ionic. Metal carbonate, sodium carbonate, potassium carbonate, whatever, bicarbonates. Whenever metal is there, they will be inorganic. Along with that, CO and CO2, they are also inorganic or not organic. Okay. Then we will take the differences between the saturated and unsaturated hydrocarbons. This is the classification we do, right? Saturated means only single covalent bonds will be there. Single covalent bonds. Unsaturated means alkenes and alkynes, minimum one carbon to carbon double bond, one carbon to carbon triple bond, right? So these will be less reactive. Can anybody tell me why saturated hydrocarbons are less reactive? Yeah, go ahead. Whoever knows.
Because they don't have availability of electrons in their outermost shell. The carbons don't have. They're
Okay,
all
okay,
four valencies are satisfied.
okay. Why the unsaturated are more reactive?
The carbons have availability of electrons because of their double or triple bonds.
Okay, fine. So we can write that single bonds means they are satisfied. Okay, so they will be less reactive as the electrons are not available for further reaction. Whereas double bond or triple bond means they are not so much stable. They want to become saturated always. So there will be a give reason question also on this. Why ethene is more reactive than ethane? Okay, the same reason you will write. The kind of reactions saturated compounds will undergo is substitution. Saturated substitution, SS, remember that. And unsaturated one will undergo addition. Again, give reason why they will undergo addition, because they want to become saturated. By becoming saturated, they will become more stable. So it all about stability. Okay. So which are saturated? Alkanes. Which are unsaturated? Alkenes and alkynes. Okay. These are the definitions you have to practice. Most of the time, name the following question will be asked, or sometimes definitions also asked. Tetravalency of carbon, catenation, homologous series, isomerism, and isomers. Isomerism is the property, right? Isomers are the compounds. Hmm? So, who will tell me what is catenation? Quickly, raise your hand. Remaining children did not. Manota, go ahead.
Tendency of an element to form chains of identical atoms. Its catenation is a property of carbon.
Yeah. It's not only about carbon, other elements also show the catenation property like sulfur, phosphorus, but they have very limited number of elements, S8, P4, right? But carbon can form a very long chain and it can form a straight chain, branched chain, cyclic. So that makes it unique. Homologous series. Ahana, what is homologous series?
It's basically a series of hydrocarbons that differ, like each consecutive member of the series differs by CH2, and
Hmm.
they have a regular structural pattern, as in they have they have a specific formula by which we can determine their chemical formula
Hmm.
based on the number of carbons.
Okay. So basically, it is a group of compounds based on how we group them based on their similar chemical properties and similar structural formulas. So they obey one general formula. All of the members of that particular homologous series will obey that general formula. Then, very important, the successive members differ by a CH2 group. If you check the mass of this, carbon 12, hydrogen 2 means 14. The mass difference will be 14 AMU between the two successive members. Okay, this is very important definition. Isomerism and isomers. Isomerism is the property. What are the keywords here? Same structural formula. The compounds having same structural formula. I'm sorry, what is the difference? Same molecular formula and different structural formula. So those compounds we call them as isomers, and that property is known as isomerism. So in this we have two types, position and chain isomerism. Remaining thing don't worry. Position means only the positions of the functional groups or double or triple bonds will be different. For example, CH2 double bond CH, CH2, CH3. Then CH3, CH double bond CH, CH3. Okay. Uh, Parth, what is the names? What are the names of these two?
Um,
Hmm.
so this one is bute, bute one in.
Okay, what is
What is
second one?
second one is butene.
Very good. Okay. So children, how to identify position isomers if they give you name? You just have to see the number. If the numbers are different, here 1 and 2, that will be position. Then when you know it is position, chain isomer, when the root word is different, because chain isomers are those where the longest carbon chain will be different. If the longest carbon chain is different, then the root word will also be different, right? One is butane, another one is 2-methyl butane, 2-methyl propane. So you can see but is one root word, prop is another root word. So these must be chain isomers. Okay. One propanol, two propanol. That will be position isomer. The functional group position is different. So this is very simple to remember. It will be asked usually for 1 mark, but for isomers you have to know the isomers of butane and pentane. Butane has two isomers. Structural formula as well as common names. Butane and isobutane. Right? If it is a straight chain, this is butane. You have to fill the hydrogens. Okay. So you write 3 carbons and 1 branch. It is isobutane. Pentane. What are the 3 isomers? Names? Anybody?
Pentane, isopentane,
Huh.
and neopentane.
Yes. Pentane, isopentane, and neopentane. Right. So what happens here? Pentane, how to remember? Simple. 1, 2, 3, 4, 5. Straight chain. Iso means looks like a T here. See, you can see it looks like a T now. So you can reduce 1 carbon in the main chain, 1 as a branch. It is iso. Neo means looks like a plus. Plus. Right? So plus. So that is neopentane. These are what? Common names. IUPAC names, so you should know, right? 5 marks will be there in section A for writing the structural formula and for writing the IUPAC names. So if you have not practiced them, then practice. I will share the file for you, okay, where I have collected all the name nomenclature questions from previous year question papers. So let's come to the alkanes part. MOP means what? Method of preparation. So all of you don't simply sit, take the notebook, write whatever I'm writing here. So if you practice writing, I think it will be more effective. So method of preparation for alkanes. In this, what you have only methane and ethane we are learning. Only these two compounds. Don't worry about others. We use two methods, soda lime and zinc copper couple in alcohol. Soda lime is a mixture of sodium hydroxide plus calcium oxide. A give reason question. Why soda lime is preferred over sodium hydroxide? Okay. Who knows? Yeah, go ahead.
Because soda lime alone is deliquescent and would attack the glass, but when mixed with when sodium hydroxide is mixed with calcium oxide, it produces soda lime, which is less deliquescent in nature and does not attack the glass.
Okay, fine. So basically, deliquescence is the keyword. Okay. Soda lime, if somebody have any problem to remember, see, soda comes from caustic soda. Caustic soda is NaOH. Lime comes from quick lime. Quick lime is calcium oxide. That's how you remember here. Hmm. Huh. So you want to get methane and ethane. We will take the sodium salt of acetic acid, CH3COONA. Sodium acetate is the common name. So what do we add here? Sodium hydroxide. Quick lime you have to write on the arrow and then write heating symbol. Don't write quick lime on the reactant side. So what you have to do, remove the sodium carbonate like this. Next we want to get the next member, which is ethane. Uh, Ethane, if you want to get, what you will do, you simply add one CH2 group between CH3 and COONA. So it will become CH3 CH2 COONA, which is C2H5 COONA. So this is called as sodium propanoate. IUPAC name. Propionate is a common name. Sodium hydroxide, same reaction, write in your notebook also. So remove the sodium carbonate, Na2CO3 plus C2H6. What is this reaction known as? Anybody can answer.
Decarboxylation.
Decarboxylation. Very good. So remember, this particular reaction is known as decarboxylation. Why? Because we are removing COO group from acetate. If there is a removal of COO group from any acetic acid, any carboxylic acid or its derivative, okay, like the salt, so it's called as decarboxylation. Second method is zinc copper couple in alcohol. So this fellow, what he does, he will give you the nascent hydrogens. Okay, nascent hydrogen means it is hydrogen atom, which is actually not so stable. Okay, but it is produced within the reaction, and within fraction of seconds it will react with our compound. So what do we use here? Alkyl halides. Alkyl halides means, for example, CH3I, methyl iodide. Common names of some compounds is also important. This is a common name what I am telling. Methyl iodide. What is the IUPAC name? Iodomethane. Iodomethane plus two nascent hydrogens. Always write the condition for organic chemistry, the chemical reactions. Zinc, copper in alcohol. So one hydrogen you give to methyl group, it will become CH4. Another hydrogen you give to iodine, it will become HI. Okay, same way you want to get ethane, C2H5, I or you take or bromide you take, ethyl bromide, same condition, C2H6 plus HBr. So if you have to call this reaction, what do you call this? Addition of hydrogen, you can call it reduction, right? We can call it as a reduction reaction, right? Okay. Next, this is the method of preparation of alkenes. Alkene method of preparation. First, we are writing only the method of preparations. Okay. Alkene method of preparation, we have two. One is dehydration of ethanol. Ethanol is C2H5OH. Dehydrating agent we will use. It will remove the water, C2H4 plus H2O. Right? So dehydrating agent, what are the dehydrating agents we can use here?
Sulfuric acid.
Concentrated sulfuric acid at 170 degrees Celsius, which is liquid. One more is solid one we can use, aluminium oxide at 350 degrees Celsius. So remember, okay, Kong sulfuric acid or alumina, anhydrous aluminium oxide. Second method for is dehydrohalogenation. What is the reagent? Alcoholic, KOH. which is hot and concentrated. Okay, same method we use for alkyne as well. If you take aqueous, then you will get the alcohol, not ethene. So here you need C2H5Br. You can change Br by iodine or chlorine plus KOH. Always mention alcoholic below the KOH. If you also remember, write hot and concentrated. Otherwise, you can just write the heating symbol. Okay. So what it does, potassium takes away bromine. So KBr is gone. OH will take away one hydrogen here. H2O is gone. So what is left? C2H4. Okay. So this is called as dehydrohalogenation. D means removal. Removal of halogen as well as water. Hydro, water. Okay. What is important? KOH, alcoholic. Method of preparation for alkynes. Same method, dehydrohalogenation, but here you have to take the starting material, different one. Here only one bromine is there with ethyl group. You have to take dibromoethene, C2H4Br2. And this is not, both bromine are not on same carbon, they are on different carbons. So this is 1, 2 dibromoethane. Okay, plus same KOH, alcoholic, write in your notebook, heating symbol. Now because there are two bromine atoms, you need 2 moles of KOH. If you use only 1 mole, you will get alkene again, which is substituted alkene, which will have 1 bromine, right? So you will use 2 KOH. So you will get 2 KBr, 2 water molecules and C2H2, which is acetylene. Common name is acetylene. IUPAC name is ethyne. Okay. Calcium carbide and water, CaC2, simple reaction, H2O. Okay. So it will hydrolyze the calcium carbonate. You will get calcium carbide. You will get calcium hydroxide plus C2H2. How to remember this reaction? It is very simple. Even if you don't remember it like this. CaC2, you break it. H2 also you can break. You can write OH and H. OH and H. So calcium hydroxide plus C2H2. Okay, simple reaction. All these are method of preparations. Now we are seeing the, yeah.
For the calcium carbide reaction, if we have to name it, is it hydrolysis?
Yeah, you can say it hydrolysis. Wherever you are breaking any compound using water, it's hydrolysis. Even preparation of ammonia by aluminum nitride or magnesium nitride, that is also hydrolysis. Now we are going to the chemical properties. Till now what we studied, method of preparation. Combustion is same for all the hydrocarbons, alkane, alkene, alkyne, even alcohols. Complete combustion, all of them will give you same products, CO2 and H2. Okay. Incomplete combustion or insufficient amount of oxygen is available, you will get carbon monoxide and water. And you know the property of carbon monoxide, which is poisonous. So based on this, one give reason question. Burning methane in insufficient amount of air is very dangerous. So first you have to tell what is forming and how it is dangerous. Okay. Main reactions what alkanes will undergo, substitution. So where the hydrogen atom of, see, RH, if I write, R represents any alkyl group. So hydrogen is replaced by some halogen. So X2 you can write. You will get Rx plus HX. This is general reaction I am writing. So in this case, what you can take, methane, CH4 plus Cl2. So CH3Cl plus HCl. So it will continue till you get all the hydrogens are replaced by HCl. Okay. Main important point here is condition. Condition here will be diffused sunlight. or you can write heat or UV. If you are asked to write an equation and if you don't write the condition, then it is not correct. So always write diffused sunlight or any one condition out of these. Okay. So this you will continue. Next one you will get CH2Cl2, CHCl3, CCl4. The CHCl3 is known as chloroform commonly. So one of the questions was asked, how do you convert dichloromethane to chloroform? Dichloromethane is this one. Next one is chloroform. So you can show that. Okay. Same thing you do for ethane, C2H6. How many hydrogen atoms are there? Those many steps will be there. Okay. So 6 steps for ethane. So instead of chlorine, you can take bromine or iodine. We do not do fluorination. Sorry, we don't do substitution by fluorine F2 because the reaction is explosive. The product formed is not so stable. Okay, so remember that point. Alkenes and alkynes, when you take mainly two reactions, only addition reaction we are learning here. Combustion is same, I already told you. Catalytic hydrogenation, halogenation. Catalysts we use here nickel. If you're using nickel, 300 degrees Celsius. You can also use platinum or palladium if you're using that room temperature. Simple reaction, ethene plus hydrogen, condition nickel, 300 degrees Celsius, C2H6. Okay, C2H2 plus H2. Okay. Again, you have to be careful here. If they ask to convert ethyne to ethane, if they're asking for 2 marks, then write 2 steps. If it is only 1 mark, then only 1 step. 2 steps, what you will write? First you convert it into ethene, then ethene say ethane, same reaction, first one, right? So nickel, 300 degrees Celsius plus hydrogen, C2H6. Okay. So what is this reaction is called as catalytic hydrogen because we are using catalyst. Halogenation means addition of chlorine, bromine or iodine, same way. So both the chlorine atoms will add across a double bond. CH2 double bond CH2. If you take chlorine, so what you will get? CH2Cl here, CH2Cl. Okay, 1,2 dichloroethane. The product name is also important. 1,2 dichloroethane. One of the question was asked. Name the following question. Name the compound formed by the complete chlorination of ethyne. Complete chlorination of ethyne. Who will tell me what is the name of the compound? Yes, Adrita.
1,1,2,2 tetrachloroethane.
Very good. 1,1,2,2 tetrachloroethane. Final product. Okay. Next comes, how do you distinguish between saturated and unsaturated? Does anyone know?
Bromine water
It's a
test.
bromine water test.
Bromine water test. So bromine in water or sometimes bromine in CCl4, carbon tetrachloride. Here children, for halogenation, important condition here is solvent. What is the solvent we are using here? Carbon tetrachloride, which is a non-polar solvent. Okay. So condition here CCl4 you have to write. Many children will have confusion, sir. We learnt about chlorine addition to alkane also. Why it is not called as halogenation? Because it is not addition there. It is substitution, and the condition you are using is diffuse sunlight. Here you are taking alkene or alkyne, and the condition here will be simply solvent, carbon tetrachloride. So this is addition reaction. So it is called as halogenation. Bromine in water or bromine in CCl4, observation will be reddish brown color of bromine disappears or decolorizes. That will be the observation. What is this? This is simply addition reaction only. Okay, C2H4 plus Br2. CH2Br, CH2Br. So what is the product you are getting here? If you use ethene, C2H4, you are getting here C2H4Br2, 1,2 dibromo ethane. Okay, if you use ethyne, 1122 tetrabromo ethane. So this is how you distinguish. Saturated will not show addition reaction. So observation you will write no change in the color of bromine for saturated. Now, how you distinguish between alkene and alkyne? That question. So there are two conditions, two reagents we can use. One, ammonical silver nitrate solution. Second one, ammonical cuprous chloride, CuCl, not CuCl2, CuCl solution. So what happens here? In both the cases, alkenes, no change. They will not show any change. But alkynes will give you white PPT with the first one. With the second one, you will get red precipitate. Okay, very important. We don't know. They can ask this question. So white precipitate and red precipitate with only alkyne. Alkenes will not show any change. So if they ask you how do you distinguish between ethene and ethyne, any one observation you can write. Okay, no need to remember equations for these. Okay, next comes to alcohol part. Alcohol, only one method of preparation is there where you use aqueous NaOH or KOH, C2H5Cl plus KOH aqueous. Then heating symbol C2H5OH plus KCl. The same if you take alcoholic, you will get KCl plus H2O plus C2H4. Okay. Now comes the chemical properties with sodium metal. This question is asked. Ethanol with sodium metal is just like metal with acid. So you'll get salt and hydrogen gas, no? Same thing. So remember, sodium will displace this hydrogen. You will get C2H5ONa plus hydrogen gas. So you balance this 2, 2, 2. Name the gas released when sodium metal is added to alcohol. That is hydrogen gas. Last one, esterification. Dehydration of ethanol we already know. Combustion we already know. Okay, esterification reaction is you need acetic acid and ethanol. You can also take methanol. You will get different product. Condition here is Kong sulfuric acid. Okay. Again, dehydrating agent. To remove water, OH and H. H2O is removed. What is left? CH3COO, C2H5. This is important. What is the name of this? Anybody?
Ethyl acetate or ethyl ethanoate?
Yes. Ethyl acetate or ethyl ethanoate. See, ethanoate is a IUPAC name. Acetate is a common name. Observation for this. What is observation?
Fruity smelling compound.
Yes. Pleasant, fruity smell observed. What is that fruity smelling compound? This one only. We call this as ester. Therefore, the name of the reaction is esterification. COO. This is ester group. Ester is also a functional group. COOH is carboxylic acid, right? Like that. In this, nothing else will be asked. They can ask you to write the structural formula of ethyl acetate. Okay, that you have to check. What is the role of Kong sulfuric acid? Dehydrating agent here. If you use methanol, CH3COO, CH3 you will get. So methyl acetate or methyl ethanoate. Okay, observation is same. Pleasant fruity smell. Carboxylic acid, these are the only important points you have to know. Glacial acetic acid is pure acetic acid. Means 100% acetic acid, no water, nothing. Okay. Vinegar is what? Vinegar is actually only 4 to 5% acetic acid. Remaining is water. Okay, that is not glacial. Glacial acetic acid, why it is called so? Because when you cool this pure acetic acid below its melting point, it will form ice-like crystals. Ice-like crystals. Okay, which will float on the surface of this acetic acid. Therefore, it looks like a glacier. Hence, it's called as glacial acetic acid. Okay, very important point in this. Chemical properties is exactly same whatever typical acids have. Acid bases we'll discuss now. There I will tell you. Whatever typical acid reactions are there, it is shown by this acetic acid. Esterification we just now discussed. Okay. Right. If you want, take a screenshot. Common names of some important compounds. Alkanes, paraffins. Alkenes, olefins. Methane, marsh gas, which is also a greenhouse gas. Ethene, ethylene, propylene, butylene, all the alkenes. Ethyne, acetylene, only first member is enough. What is the first member of alkene? Ethene. First member of alkyne? Ethyne. First member of alkane? Methane. There is no methane or methine. Huh? Methanol, methyl alcohol. Ethanol, ethyl alcohol. Methanol is aldehyde. First member of aldehyde, formaldehyde, common name. Ethanol, acetaldehyde. Methanoic acid, formic acid, ethanoic acid, acetic acid. Okay. If you want to add, you can also add iodomethane, one alkyl halide. Okay, is known as methyl iodide. Same way, chloroethane. If you take ethyl chloride. So sometimes they will ask you convert ethyl chloride to ethyl alcohol. So you should know the common names. Okay. Huh. Now questions. So comment your answers in the comment section. First one. We'll go fast. What is the answer for the first one? Which of the following formula organic compound? Right. Second one. Second one is C. C2H4. So burns in oxygen, carbon dioxide, water vapor, all of them will show. Decolorizes bromine means it should be unsaturated. So it is second. Okay. Which of the following is the structural formula of alkene? A. CH3, CH2, CH2, CH3. Okay. B is not alkene, it is alcohol. C is carboxylic acid. D is alkene. Fourth one. Pentane. How many covalent bonds overall? Pentane, how many covalent bonds? Hmm? 1, 2, 3, 4, 5. This fellow. Okay. Okay. All of you getting C? 16 covalent bonds. So you just have to write the structure and count the number of bonds. That's not big difficulty here. Which of the following is known as illicit alcohol? Illicit alcohol. Spurious alcohol only. Okay. Illicit means illegal. Which of the following represents a homologous series? All on the answers are C only here. Okay. Methane, ethane, propane. Which of the following is an unsaturated compound? Unsaturated compound. B. Very good. The functional present in acetic acid. Very good. Organic compound undergoes addition, gives a red color precipitate with ammonical cuprous chloride. Therefore, the organic compound could be very good ethine. Huh? The formation of 1,2-dibromo. Read this question and understand, then type your answer. Ethene and bromine is an example of. Very good. Whoever writing the answer as 4 is correct. So this is ethene plus bromine addition reaction. Different kind of questions, Mainly you will be asked observations and write the balanced equations, conversions, these things only. Addition of ethyl alcohol to acetic acid in the presence of conc sulfuric acid. Observation will be what? Pleasant, fruity smell. Right. Okay. Only important questions only I have included here. Okay. Identify the term here. Ice-like crystals formed on cooling in organic acid sufficiently will be glacial acetic acid. Very, very good. Glacial acetic acid. Second one, hydrocarbons containing a triple bond used for welding purposes. Not alkyne, ethine. Specifically ethine. The property by virtue of which the compound has a same molecular formula, different structural formula.
Isomerism.
Isomerism, very good. Reaction when an alkyl halide is treated with alcoholic potassium hydroxide. What do you call this reaction? Alcoholic KOH if it comes, what is it? Dehydrohalogenation. Next one, catalyst used in the conversion of ethine to ethane. Any catalyst you can.
Nickel 300.
Nickel, name you have to write nickel or platinum or palladium. Any one is correct. The type of reaction alkenes undergo?
Addition.
Addition. Comment your answer. Second, hydrocarbon which contributes towards the greenhouse effect. Very good. Methane, which is commonly called as marsh gas. Uh, this one, 31. Uh-huh. Many of you doing mistake for this. Substitution is correct.
Sir, I checked this answer again with the question again with the answer key after we had discussed it. I think halogenation is also accepted for some reason.
It may be because we are adding halogen there. Okay, but basically alkanes are undergoing substitution reaction. So here halogenation mainly we use for addition of halogen to an alkene or alkyne, right? So best answer will be substitution. Okay, an organic compound used as a thermometric liquid. Yeah, ethyl alcohol or ethanol we use in the thermometer we use. No? Last question. I have not included any balanced equation and all because we already discussed it. Here see, they have given A, Br2, CCl4, CH2Br, CH2Br. Draw the structural formula of A. A will be what? A will be ethene. So just remove Br and put one double bond between carbon. Ethene. So you have to write the structural formula of it. What type of reaction A has undergone? Addition. What is your observation? Reddish brown color of bromine disappears. Apart from this, okay, 5 marks for naming and writing structural formula. I have practiced it plenty of times with you. You should not lose any marks in this. So see, if you have not practiced, then practice it. You will have plenty of previous year questions. I will send you past 10 year, not 10 year, 2010 to 2019 questions with answers. One PDF file is there. I will share it with you. You can go through it. Sure. So this is all about organic chemistry. I covered all the points, most of them. Uses part you have to read. Come to next simple topic, periodic table. We'll take periodic table. Periodic table we do have, but we have less number of marks in this. Maybe in section A 4 marks, section B 4 marks. That you will have options in section B. So what definitions you have to focus on here? Ionization energy, electron affinity, electronegativity. Let's see the trends. Ionization energy, electron affinity, electronegativity, non-metallic nature. NM nature means non-metallic. All of them have same trend. Okay. Across the period and down the group. Across the period, what happens? Ionization energy will increase. So all of them will increase. Down the group, all of them will decrease. So no need to remember them separately. Group them and remember. Opposite of that will be this one. Atomic size. Down the group, what happens? Atomic size will increase. Across the period, what happens? Atomic size will decrease. Same for metallic nature.
So
Hmm.
oxidizing power, how does
We'll
like
discuss that. Okay. Here, give reasons is there. No? There we'll discuss it. So here they will ask you give reason why so and so nature property is decreasing or increasing across the period like that. So always use two terms. Use atomic size, what is happening, and nuclear charge, what is happening. For example, if they ask you, give reason, ionization energy increases across the period. Okay. So you will say atomic size across the period is decreasing because the nuclear charge is increasing. Hence, more energy is needed to remove an electron. Hence, ionization energy increases.
So is ionization energy the same thing as ionization potential?
Yes.
So we can
Ionization
use them
energy and
interchangeably.
ionization
Yeah.
potential, ionization enthalpy, all of them are same.
Okay. Thank you, sir.
Different names. If they ask the question on atomic size itself, then you will use number of shells. Along with at nuclear charge, you will say number of shells, what is happening to them. Then you will give reason. Okay. Next, what other give reason questions can be asked? Alkali metals are good reducing agents. Group 1 elements. Alkali metals are group 1. So they will have one valence electron. They can easily lose that electron. Means they are very good electron donors. If they are giving electron means they will reduce other substances. Hence they are very good reducing agents. Okay. What I am telling now, write the keywords. I am not writing everything here. Halogens are good oxidizing agents. Why? Because halogens are in group 17. They have 7 valence electrons. They have high electron affinity, means they will readily accept electrons. Hence, they will oxidize other substances. So, same thing you can think if they ask you the question on oxidizing power or reducing power. What is happening? You are moving from metals to non-metals in the periodic table, left to right when you move, metals to non-metals. So metals are good reducing agents, non-metals are good oxidizing agents. So their power of oxidizing other substances increasing because they readily accept electrons. Same thing you can write for metals reducing. Okay. Reason for periodicity. Reason for periodicity will be a recurrence of similar electronic configuration. Okay, recurrence of similar electronic configuration, or they will ask you why the elements in the same group have similar chemical properties. Same reason you will write. Recurrence of similar electronic configuration and having same number of valence electrons, which is responsible for chemical properties. Okay. Yeah. Any other doubt in this?
so whenever they say like left to right or like which place will the two elements be? So we have to talk about R left and R right,
Yes.
right?
Yes. Yes. Our left only. Okay. I have included one such question. We'll discuss that. Some important points. So you can make note or you can take the screenshot here. Most electronegative element is which one? Most electronegative element.
Fluorine.
Fluorine. Very good. Highest, the element with highest ionization energy or ionization potential?
Helium.
Helium. Very good. Element which has highest electron affinity?
Chlorine.
Ah, chlorine. Why? Because there is an exception in the electron affinity trend. So usually down the group FCl down the group electron affinity should decrease. But because of its smaller size and intermolecular repulsion, the fluorine has lesser electron affinity value than chlorine. So if they ask you to arrange the following in the decreasing order of electron affinity, Cl comes first, then F, then Br, then I. Okay, this is very important. Only exception, don't apply this to electronegativity. Many children are doing that, confusion. Electron affinity is different. Okay, one more point, electron affinity has a negative value because it is the energy released. Ionization energy is the energy absorbed, means positive value, or energy given to the atom. Electronegativity has no dimension, means it is a dimensionless quantity. It's just a number. It is not even a quantity. Okay, it's just a number given. Who gave that? Many scientists gave, but we use Linus Pauling scale. Linus Pauling scale for electronegativity values. Okay. Okay, let's see some questions here. Comment your answers for the first one. Just type the option. D, helium, we just discussed. For the second one, largest atomic radius among the following: carbon, nitrogen, lithium, beryllium. Very good. So you have to see whether they are in the same group or same period. Then you decide. Okay, they are in the same period means left to right it decreases. Whose electron affinity is 0 in period 3? Argon. See, remember children, noble gases, their electron affinity will be 0. Because I have asked here period 3, so helium, neon, then argon. So argon is the answer. Period 2 will be neon. Okay, next one. Third period, 16th group. It will have dash electrons in its valence shell. 6 electrons. Very good. Electron affinity is maximum in halogens. Okay. Left to right. Don't consider inert gases. 0 means, see, more the negative value, more will be electron affinity. If an element A belongs to period 3 and group 2, then 3 shells, 2 valence electrons. Very good. This is another type of question that can be asked, increasing or decreasing order for the elements based on the different properties. Okay. So increasing order of the number of electron shells. This one too easy. Increasing order means start from the lower. Helium say neon, neon say argon. Increasing electron shells. Increasing ionization energy. I told you to remember the first group elements like this: high, Lena K, Ruby, close friend. High, Lena K, Ruby, close friend, if you remember. Then down the group, what happens? Ionization energy decreases. So increasing you have to write, right?
So
So
what's for the alkaline earth metals which it created?
alkaline earth metal, beta, mange, car, scooter, bap, razi. Okay, beta,
Okay.
mange, car, scooter, bap, razi. Okay. So increasing order will be correct, huh? Ionization energy. See, very careful. You know the answer many times. Increasing, decreasing, you will do confusion. You will have. Don't do that. Increasing electronegativity. Most electronegative is fluorine. So then write reverse. Right. Increasing atomic size. Lina K. Hmm. So these type of questions also will come on this. Apart from this, we have this type of question. Okay. Where they will give you a periodic table, extract of periodic table. This kind of questions are very simple. Hmm. So you have to see which option is correct and just write it. A. Who will tell me the answer for A? Just tell. Identify the most electronegative element from this. Go ahead.
J.
Sir J.
J. Very good. So fluorine we know. So where is the position of fluorine here? But they're given J. Okay. Identify the most reactive element of group 1. Most reactive. Anybody?
Sir
R.
A.
R only, na? Remember, down the
Well,
group, lesser the ionization energy, more reactive it will be. Means what? Most readily it will lose electron, na? So more reactive. C. Identify the element from period 3 with the least
M.
atomic size. Which one?
M.
M. Right. How many valence electrons are present in Q?
6.
6. Uh, Valency is different. Valency if they ask 2, but valence electrons are 6. Which element from group 2 would have the least ionization energy?
T.
T.
T. Very good. Identify the noble gas of the fourth period.
Y.
Y.
Why?
Y.
See, this kind of question, na, very simple question. If it comes, don't leave it. Hmm. This is the last type of question I have included here. Means they will give you the position. So you have to write left or right. So always take your left and your right. Okay. So here element B is placed left to element A. So B is left, A is right. Now you know they are in the same period. Okay. So they are in the same period. Then you can apply all your knowledge about the trends across the period down the group and all. You can say this. Okay. Element B would have dash metallic character than A.
Higher.
Higher.
Next, element A would probably have dash electron affinity than
Higher.
B.
Higher.
Is also higher. Yes.
Higher.
The element A would have dash atomic size than B.
Smaller.
Smaller. Okay, higher, smaller will be the answers. Fine. Okay, study of compounds. Okay, all the 4 chapters in one thing. So again, take your pen and paper, practice the equations, what I'm giving here. So mainly, what type of questions are asked on study of compounds? Balanced chemical equations, observations, the gas released, laboratory method of preparation. This is for only three: HCl, HNO3, and NH3. HCl, HNO3 have similar method of preparation, so common questions. Manufacturing process, again, there is no manufacturing process for HCl, so we have to study only for HNO3, NH3, and H2SO4, and the questions asked on that. Okay. Huh. Laboratory method of preparation for HCl and HNO3 is the same. So what do we use here? Conc sulfuric acid, which is non-volatile. So for NaCl, if you use, you will get HCl, NaNO3 or KNO3. If you use, you will get HNO3. So what we are having here? Conc H2SO4. Byproduct below 200 degrees Celsius will be sodium bisulfate or potassium bisulfate. Okay, for both. Above 200 degrees Celsius, Na2SO4. Based on this, many questions are asked. Why we don't do it above 200 degrees Celsius? Sodium sulfate form will be, it will stick to the walls of the container. It is difficult to remove it. and fuel will be wasted. There is a chance to breakage of the glass apparatus. Method of collection for HCl method of collection will be what? It is heavier than air, so it will push the air upward, so it is called as upward displacement of air. Upward displacement of air. Drying agent is same for HCl. Kong sulfuric acid itself is also a drying agent. Again, why don't we use calcium oxide or phosphorus pentoxide? Because HCl is acidic in nature. It will react with calcium oxide and phosphorus pentoxide. Hence, we don't use them. For HNO3, same questions, but there is no drying agent. There is no collection method. Okay. One question they can ask you, why it is yellow in color? That is because of the dissolution of NO2 gas, which is reddish brown, formed by the decomposition of HNO3 itself. Therefore, it will have yellow color. Okay. How do we remove that yellow color? By passing plenty of air or by passing carbon dioxide. For ammonia, if you come, there are two methods. First one is to take alkali. Usually we take calcium hydroxide. Then ammonium salt. Usually we take ammonium chloride. Right? Then heat it. Heating is important. So you will get calcium chloride plus ammonia plus water. Okay. So balancing you can do. So this will be there. Another method is using magnesium nitride or aluminum nitride. So metal nitrides. You will add water. Which water? Warm water. Warm is important. If you don't write warm, marks will be gone. MgOH2 plus NH3. Again, hydrolysis only. ALOH thrice NH3 for aluminum nitride. Okay. So here for both HCl and NH3 have same glass rod dip, you will get white as fumes. That is the identification. Manufacturing process mainly focus on catalytic equations. Anyway, you know all of them is better, but if you don't remember all of them, mainly focus on catalytic equation. Haber's process is for manufacturing ammonia. So N2 plus 3H2. Reversible reaction. Symbol should be reversible. 2NH3 plus H heat. Okay. So catalyst we use here finely divided iron. Promoter is trace amount of molybdenum. Then temperature is 450 to 500 degrees Celsius. Pressure will be above 200 atm. So if they ask you to write catalytic equation, everything you have to write. All of them. Then for Ostwald process, there are 4 steps, but we have 4 process, but we have only one catalytic equation. First method, NH3 plus O2. This is not reversible. This is platinum 800 degrees Celsius. NO plus H2O plus heat. Balancing you can do. I think 4546 something is there. Okay. Platinum is the catalyst we are using here. For Ostwald process, we have this one. For contact process, there are SO2, SO2 to SO3, SO3, 4 steps here. So only step here you have to see is SO2 plus O2. Again, this is also reversible. You will get SO3. So what is the catalyst we are using here? V2O5. Or remember, we can also use platinum, but preference will be given to vanadium pentoxide. Temperature is 400 to 500. Pressure will be 1 to 2 atm. Maybe in your textbook they have also given promoter for this, K2O, potassium oxide. Okay.
So for Ostwald's process, won't it be NO2?
No. Ostwald process, only this one, first step. Second step will be NO plus O2, NO2. Right? So you have
Okay,
to write for Ostwald process only this one.
okay, sir.
Catalytic equation. So this includes maximum number of questions here. What is the catalyst used? What is the temperature? What is the pressure? What is the equation? Remember, for Haber's process and contact process only, you have reversible. No other reversible reactions here. And all of these are exothermic heat. Okay. Apart from this, what we have, fountain experiment. So it is same for ammonia and HCl, except the litmus solution color will be different. So here what they will ask you, mainly what is the aim of the experiment. Can anybody tell me what is the aim?
Sir, to show the high solubility of hydrogen chloride gas and ammonia gas in water.
Yes, HCl gas or ammonia gas in water. That is the aim, not to check its acidic nature or basic nature. Okay. Color change will be there. Blue to red list, red fountain for HCl, blue fountain for ammonia. Inverted funnel arrangement. Why we use this? To make the ammonia solution aqueous or hydrochloric acid, not the gases, for the acids and the solutions, right? So what are the advantages of this? One, it prevents back suction. Second one, provides larger surface area. For what? For dissolution of the gas. If they ask you any question on inverted funnel arrangement, remember these 2 points. Prevent back suction of water. Okay, larger surface area for dissolution of gas. Same for both ammonia and HCl. Important equations. Okay, here I have not included the general acid properties that we'll see in acid, bases and salts. It is same for all of these. Same for HCl, HNO3, H2SO4. Okay, I have written here only special reactions. So what is this first one? Na2S2O3 plus HCl dilute. This is called as sodium thiosulfate. I'm not sure whether they removed it or not, but I have included it here. Okay. So simply you have to remember, you already know one reaction. What happens? Sodium sulfite with acid. Sodium sulfite with acid, say with HCl itself. You will get what? Salt plus water plus SO2 gas, sulfite and bisulfite. Same products you write here, NaCl plus H2O plus SO2. What is left? One extra sulfur is there, Na2S2O3, Na2SO3, no? S is difference. So that S you will write here, which is yellow precipitate. So if they ask you,
So observation will be yellow precipitate.
yes, you can write yellow precipitate, or you can also write the SO2 test.
Oh.
SO2, what you will write? Lime water turns milky and changes the color of acidified potassium permanganate and dichromate from so and so. Okay. For MnO2, it is black in color. MnO2 is black. So here you will get salt, MnCl2, water plus chlorine gas. So here observation will be greenish yellow gas. Fine. One more important one is with silver nitrate. This is basically the test for chloride anion. So if they ask you to differentiate between sodium chloride and sodium nitrate, distinguish between, they will ask you magnesium chloride or magnesium nitrate. You will use silver nitrate solution. So what you will get here? AgCl plus HNO3. AgCl is a white precipitate. And important point about this is it is soluble in excess of ammonia solution. Don't write ammonia, it's ammonia solution. So this is how you distinguish between sodium chloride and sodium nitrate. Sodium nitrate will not give any precipitate. Both are nitrate, right? For ammonia, important things we have included here. Ammonia plus oxygen, pure oxygen, or you can say excess of oxygen. But if you just take air, it will not burn in air. It needs pure oxygen for burning. So in that case, what you will get? N2 plus H2. Okay, the color of this flame, green flame. In some textbook, it is given greenish yellow flame also. Okay, that is observation. This is in absence of catalyst. Same reactants in presence of catalyst, we just discussed previously, you will get NO plus H2. Okay, this is a catalytic reaction. Ammonia with copper oxide. Here it is acting as a reducing agent. Copper oxide will be reduced to copper. Ammonia will be oxidized to water and nitrogen. One of the question was asked, which of the following is correct for this? They gave ammonia get oxidized to water vapor and nitrogen. That will be correct. Copper oxide is reduced to copper. Same you can write for lead oxide also. So you will get lead here. Remaining thing is same. Ammonia plus chlorine, we have two conditions here, right? One case excess of chlorine, another case excess of ammonia. So in excess of ammonia, if we use, we get the products NH4 Cl plus N2. Okay. Another case, if we use excess of Cl2, what do we get? NCl3 plus HCl. Balancing you have to do. Just writing the products. Okay. So remember, excess of NH3 if you are using, both the products should have N. Excess of Cl2 if you are using, both the products should have Cl. That's how you remember it if you are having confusion. Okay. Now difference between liquor ammonia, liquid ammonia. This is saturated solution of NH3 in water. Means take the water, dissolve it, maximum amount of ammonia it can dissolve in it. That is called as liquor ammonia. Liquid ammonia is simply the ammonia in liquid state. When you cool it below its condensation point, it will turn to liquid, right? Ammonia in liquid state. Now, if you bring a simply dry red litmus, it will not change the color because there should be moisture. Okay, always if you're telling any paper, always add moist, like moist red litmus paper, moist blue litmus paper, moist lead acetate paper, moist starch iodide paper. So add this moist word there. So this is a test for ammonia gas Nessler's reagent. So what you will get? Brown color or pripity, brown pripity when ammonia is passed through Nessler's reagent. Liquid ammonia is used as a refrigerant. This is a give reason question. Okay. Can anybody give me the reason for this? Go ahead.
High heat of vaporization.
High heat of vaporization. So what happens?
It has a lot of.
Go ahead. Go ahead.
Go ahead.
No, go ahead. It's okay.
Yes, Adrita, go ahead.
It has high latent heat of vaporization, which means it absorbs more heat energy to convert into a solid, liquid from the gaseous state. Therefore, it allows the water around it to freeze into ice. Also, it can be easily liquefied as compared to other gases.
Okay, right. So yes, these are the points you have to add. Latent heat of vaporization is more, it needs more energy to convert into gas. Therefore, it is a very good refrigerant. Okay. These are the two special things. In the preparation of ammonia, we can use ammonium chloride, we can use ammonium sulfate, but we don't use ammonium nitrate or nitrite, because for ammonia you are heating. Okay, so for ammonia you're heating. Now what you will get here? It will decompose. So you will get nitrous oxide, which is also known as laughing gas, plus H2O. And ammonium nitrite will give you nitrogen gas plus H2O. So these are mainly the nitrates. They are explosive in nature. So usually we avoid to heat them, especially the ammonium containing nitrates and nitrites. Okay, so this is one of the important points.
So could you go to the previous one, the one before this?
Hmm?
Thank you, sir. So I wanted to clarify one thing.
Yeah.
There was a question in some year paper where it was like ammonia gas is passed through CaO quicklime and then it is made to react with a litmus paper. So in the answer, it was an MCQ question, so there should be no reaction, right? The litmus will not change color.
Basically, if they don't mention moist litmus, then there is no change in color. If they
Yeah.
mention moist litmus, then there will be change in color. Yeah.
But if they suppose they just say ammonia gas and they don't mention that it has been dried by quicklime, then can we
Then
assume
also
that?
no change. Then also no change. It
Okay.
must be moist. Okay.
Okay.
Hmm.
Thank you, sir.
Yeah. And ammonia is drying means you are just removing the moisture. But usually, if you just take the ammonia gas and hold dry litmus paper, you will never get any change in it. Always we
Okay.
have to take moist.
Got it.
Okay. For in detail, I have written here for Ostwald process these and all. So this is always you have to practice this. First step is the catalytic equation. Second step, you have to reduce the temperature to 50 degrees Celsius. The temperatures and all very important here. Okay. Then you will get the third step where you will absorb NO2 gas over water along with oxygen. Here the ratio of ammonia is to air will be 1 is to 10 volume. So the give reason why 10 volume, because you are using oxygen in every step in Ostwald process, and oxygen is only the 20% of air. Therefore, we need more amount of air. Okay, that's the reason. Coming to the chemical properties, typical acid property I told you, we'll learn it separately. When you come to nitric acid, even if it is in diluted form, it is a very good oxidizing agent. So we have two conditions here. Cold and dilute nitric acid if you use, when it oxidizes other substances, it itself will undergo reduction, right? So it will form nitrogen monoxide plus water as the byproducts. You will get nitric oxide or nitrogen monoxide only if it is cold and dilute. In all other cases, you will get NO2 gas plus H2O as the byproducts. Okay, whether it is concentrated or hot and dilute, you will get NO2. So when do we know this one? If you are given the reaction between carbon, sulfur or copper with any of these two, then only you have to check this. So carbon will be oxidized to carbon dioxide in both the cases. Sulfur directly to sulfuric acid. Don't write SO2 gas here. SO2 you will get for Kong sulfuric acid. So copper will be oxidized to copper nitrate. What are the byproducts? It depends. If it is cold and dilute, you will just add NO plus H2O in all the cases. If it is second case, you will add NO2 plus H2. And whenever there is concentrated, you always write the observation reddish brown gas released. That will be your observation if they ask you observation. Clear? Very simple to remember.
So if a condition is cold and dilute, cold and concentrated, then what exactly?
Same thing. Concentrated if it is coming NO2 and H2O.
Okay.
Brown ring test. This is done to detect the nitrate anion. Okay. So here mainly what is brown ring compound formed? Name of that. That will be nitroso ferrous sulfate. The formula will be FeSO4.NO. IUPAC name will be what? Nitroso iron 2 sulfate. This is IUPAC name. Ferrous means common name. Right? This is the compound. Here one give reason question why FeSO4 is freshly prepared. Because if we prepare and keep it, it will oxidize to ferric sulfate. Fe will become Fe plus 2 will become Fe plus 3. Then it will not give you positive test for brown ring because there is no FeSO4. Okay, that one question can be asked.
So,
Yeah.
sir, in the reaction given the textbook that for the grounding test,
Don't worry about the reaction here.
the,
Hmm.
the valency of the iron changes over there.
Yeah, that is also one more product you will get. Okay, but don't worry about the equations for this. Only the name and the formula for this. One mark
Oh,
question.
okay.
Observation will be brown ring only. That is the observation. What you will write? Brown ring, brown colored compound. Actually, what is that brown ring? Means brown colored compound. This one at the junction of two layers. At the junction of two layers. If you see the image in your textbook, you will see the two layers formation in the test tube. Right? So at the junction of two layers, you will have brown ring. For contact process, four steps. First step, S plus O2, SO2. One more reaction also you have to remember. Iron pyrite. Okay. So you will get ferric oxide plus SO2. One of the questions they have asked, write the two methods for making SO2 gas in contact process. So both are important. Next, this is the catalytic equation we discussed. Next, SO3 plus oleum, how you form? Oleum or pyrosulfuric acid. Children always write concentrated or dilute whenever you're writing the acid. Concentrated or dilute you have to mention. Okay. So you will dissolve SO3 in concentrated sulfuric acid to get the oleum. Then oleum, after dilution with water, you will get the sulfuric acid. Why don't we dissolve SO3 in water directly? Because it is highly exothermic reaction and forms the mystery droplets of sulfuric acid. That will be the give reason question.
So the sulfuric acid obtained at the end of contact process is concentrated or dilute?
It depends upon our intention, like how much concentrated we want, that much water we will add.
So in general, we don't need to mention concentrated or dilute if it's
No
a
need,
name.
no need.
And for nitric acid, same thing? Or
Yes, that's also same.
okay. Thank you, sir.
So nature of sulfuric acid, again, diluted form. It will be a typical acid. Only in diluted form, it will act as a typical acid. For all these remaining three, it will always be concentrated form. Okay, for all these three, concentrated sulfuric acid you have to write. Mainly what will be asked here, give reason, not balanced equation, observation, these kind of, or what is the nature of sulfuric acid in this case. Non-volatile nature, where we use to make HCl and HNO3, right? That is non-volatile nature. Oxidizing agent, same what we learned for carbon, sulfur and copper, same three. Carbon will be oxidized to carbon dioxide, sulfur to sulfur dioxide, copper to copper sulfate. So in this case, what is the byproduct, right? So here for Kong sulfuric acid, when it undergoes reduction, it will always give you SO2 plus H2. There is no exception here. So CO2 plus SO2 plus H2. Here for sulfur, you already have SO2, so H2O. Copper, this plus this. Okay. And for all these three, if you want to remember, you will always use 2 moles of Kong sulfuric acid for all these three reactions. Dehydrating property. Dehydrating property is for sugar, glucose, blue vitriol, and we have seen dehydration of ethanol. So that is also dehydrating nature of Kong sulfuric acid only, right? So equation is what? C12H22O11 for sugar. Remember, sugar formula is not C6H12O6. That is for glucose. Then you will write on the arrow Kong sulfuric acid. What you will get? Carbon plus H2, right? 12C11H2. Observation for this is black spongy mass of carbon rises up. So what is this carbon formed? It is called as sugar charcoal. Sugar charcoal. Same for glucose. Glucose you have to use C6H12O6. Okay. Blue vitriol, you know already. Blue vitriol is copper sulfate pentahydrate, which is blue in color. So it will turn to white amorphous solid, right? White amorphous solid plus water. On the arrow, write Kong H2. So here again, what is the equation? What is the observation? These kind of questions only will be asked. Okay. These are the three properties of Kong sulfuric acid. special reaction to detect the sulfate. Okay, so here nitrate, lead nitrate, you will get lead sulfate plus HNO3. Balance it. Then barium sulfate plus HCl. So here what is so important about this? Most of the time this question is asked barium sulfate and barium chloride. Means you use lead nitrate to differentiate between HCl and H2SO4. Dilute HCl and dilute H2SO4. So dilute form. Okay. So you'll get lead chloride here plus HNO3. So here both have white precipitates, lead sulfate and lead chloride. But lead chloride dissolves on heating. That's the difference. Dissolves on heating. Lead sulfate remains insoluble on heating. Insoluble on heating. This is very important. Distinguish between the question. Okay. Lead nitrate with HCl and H2SO4. Barium chloride sulfuric acid, barium sulfate. Barium sulfate remains insoluble in mineral acids like HCl or HNO3. This is also white precipitate. All of them are white except what? Copper, iron. These are only colored, you know, right? Remaining all will be white. So, okay, question time. First one, comment your answer. Very good. Which of the following is not a property of either dilute or concentrated? Whether you take dilute or concentrated is not volatile. Second one. Platinum. Platinum will not react. B. Next one, third one. Nice question, this one. Yeah. Fourth one, C. Blue color compound means copper containing. Black color substance will be what? Copper oxide. Copper oxide is a base. Sulfuric acid is an acid. Acid-base reaction will give a salt, copper sulfate. Right. C. Next one. Lead nitrate. Yes, we just discussed this. Next question. Three. Highly soluble in water. Okay, next question. Dried by drying agent will be Kong sulfuric acid. Okay. Next, this one, read question carefully. You have to get the nitrogen gas, not ammonia gas. Whoever given answer 2 is correct. I told you, na, ammonium nitrate on decomposition gives you nitrogen plus H2O. Heating only. You are not adding anything to this. Ammonia, next one. Magnesium nitride. Very good. Next one to simple. Brown ring test. Chalo. Nitrate. This one. Think and comment your answer. CU is correct. So you can say if they ask you to distinguish between dilute sulfuric acid and concentrated sulfuric acid, so you can simply use copper metal. Copper metal, because copper is below hydrogen, it will not react with sulfuric acid to give you hydrogen gas. So there is no reaction with sulfuric acid. Which form? Diluted form. Concentrated form we have seen, it will get oxidized to copper sulfate. So you will get SO2 plus H2O. So this is how you distinguish between dilute and conc sulfuric acid. Next one, give a balanced equation. This one I have included so that, okay, this one we'll also discuss. See, lead sulfate from lead carbonate. Lead carbonate say lead sulfate directly you can't do. First you convert it into lead nitrate, then to lead sulfate. So why? Because this is solid, lead carbonate is also precipitate, this is also solid. Solid to solid you can't do directly. Huh? So this one is what? All the metal nitrates. Remember this point? I told you plenty of times. All metal nitrates are soluble. Are soluble. Whatever metal nitrate you take. So this is a solution. So first what you will do here? You will add nitric acid to this. Which one? Dilute. Huh? Then you will get this one plus what else you will get? CO2 plus H2O. This you will take, then you will add sulfuric acid. Which one? Again, dilute. The lead sulfate plus HNO3 you will get. This is therefore this is for 2 marks now. You have to see that. So 2 steps. This is another type of question where they will ask you to find the anions based on the information given. So read the first one and comment your answer. Which anion is present in compound X? Nitrate. Very good. So write the name. Nitrate. Reddish brown gas. Next one.
So I'm assuming the gas has no effectors for the acidified K1O4 and all that.
That one I cut. So it will be carbonate. Simple. So this is a test for carbon dioxide gas. So carbon dioxide will form by carbonate. So anion will be carbonate. Again, what other type of question? Picture study based on your fountain experiment, which we already discussed. So based on the color of the litmus, you can say whether the gas Y is HCl or NH3. So blue litmus, if you're taking, it must be HCl gas. So you write hydrogen chloride gas. Don't write HCl gas. Name you write hydrogen chloride gas. These are small things, but this is where you lose marks. What property of gas Y does this experiment demonstrate? High solubility in water. Name another gas, ammonia. Don't write the formula. Write ammonia gas. Another type of question is find or identify the gas evolved. Potassium sulfide is treated with dilute hydrochloric acid. Sulfide will give you what? SO2 gas. So write the name, not formula. Write the name. Sulfur dioxide. Concentrated hydrochloric acid is made to react with manganese dioxide. So this one to chlorine gas. Very good. One more question I will include here. When sulfur is treated with concentrated nitric acid, what gas is released? Sulfur is treated with concentrated nitric acid. What gas is released? Don't write sulfur dioxide. Nitrogen dioxide. Because here you will get sulfuric acid as the product. But the same as if you take conc H2SO4, then you will write sulfur dioxide. Okay, be very careful. Last, again, picture study. They can give you any picture study, laboratory preparation of anything. They just give you one example here. So name the gas collected in the jar. This is inverted, slanting position of RB flask means this must be alkaline in nature, means it must be ammonia gas, right? Again, give reason why it is kept in slanting position. This is one more question. Anybody know why it is kept in slanting position?
So that the water doesn't condense and trickle back and crack the glass apparatus.
Yes. So because we are doing this at a high temperature, if you keep it straight like this, we are also getting water as a product. So it may condense at the cooler parts of the RB flask and trickle back into the RB flask. So because it is hot, it may crack. To avoid that, we keep it in a slanting position. Simple. Okay. Write a balanced equation. How is the gas being collected? So ammonia gas is lighter than air. We are keeping it in ulta, right? It will be downward displacement. Yes. Downward displacement of air. Again, why do we don't collect it over water? Because whether it is NH3 or HCl, both are soluble, highly soluble in water. Therefore, we don't collect it. How we'll find the gas jar is full of gas? Bring a glass or dip it in conch HCl. We'll get white dense fumes. Okay, this is the last question. So main important chapters we finished here. Next we will take simple one, chemical bonding. Here, see, chemical bonding chapter is very easy. Mainly you have to work on electron dot structures. How it is there in your textbook. Same way you write if you don't want to lose marks. Okay, definitions, what you have to check. The ionic bond, covalent bond, coordinate bond, these definitions. What is electrovalency and covalency? Electrovalency is for ionic compounds, covalency is for covalent compounds. Okay, the definitions are given, so check them. Next important is conditions. Very rare questions, but they may ask you, like not direct question, maybe indirectly. For electrovalent compounds, see, electrovalent means ionic. Ionic means there will be a metal and non-metal. So we know that metals have low ionization energy. So one condition is low ionization energy. Non-metals have high electron affinity. So that is another condition. Then if you take metal and non-metal, there is a large electronegativity difference. So that is the third condition. For covalent, always it is between two non-metals. Both are non-metals means their property will be similar only, right? They both will have high electron affinity, both will have high ionization energy because they are non-metals. And the difference when you take electronegativity difference is very negligible or even zero when the same atoms are combining. So these are the three conditions for covalent bond formation. Electron dot structures, I think you know how to do them. Will not go through it, but common mistakes I tell you. Whenever they ask you, usually for hydronium ion or ammonium ion, so always see whether they are asking you to the formation of this particular ion. Then you show what are the reactants: H2O plus, H plus, then H3O plus. Okay. Otherwise, if they don't ask you formation, simply give electron dot structure. Then you can just write the hydronium ion dot electron dot structure. So it will be O dot cross dot cross dot dot H dot dot. What is the common mistake you do? You don't do this. You don't put this plus mark. That you have to avoid. Ammonia also same thing, dot cross dot cross dot cross, then dot dot. So here simply write hydrogen atoms. Overall H plus. Okay. Remaining you have to practice. We can't discuss all the things. I just told you. Definitely you will get minimum 2 marks on this. There will be a question on this. Definitely. Polar and non-polar covalent compounds. This difference you should know. Polar and non-polar definitions you have to check. The shared pair of electrons are equally distributed or not equally distributed. That will be the difference. Only polar compounds, which one we studied? HCl, NH3, water. These three. Remaining all are non-polar. Main question is CCl4. Okay, CCl4 is non-polar. Nitrogen triple bond, oxygen double bond, hydrogen single bond, chlorine single bond. Again, what else they will ask you? What are the number of lone pairs? Ammonia has 1 lone pair, oxygen has 2 lone pairs, HCl has 1, 2, 3 lone pairs. Okay, so you know already this.
So for CCl4, how many lone pairs are there?
Every chlorine will have 3 lone pairs. So 3 into 3.
I came across this question where it was like those fill in the blanks with options in the brackets, and they asked which one has no lone pairs, and the answer was CCl4. Why?
Yeah, That is incorrect also.
Okay.
Because it has more number.
Yeah.
Mainly,
Okay.
it will be. They can reframe the question here. See, ammonia. There may be options are ammonia, water, and CCl.
Yeah, those were the
Ah.
options.
So if you check here, central atom we call it here. Nitrogen is the central atom, oxygen is the central atom, carbon is the central atom.
Carbon is the central.
So carbon do not have any lone pairs. Based on
Okay.
that, we can say. But the question we did not learn that. No,
Yeah.
question is
Okay.
not correct. Give reason questions. What type of questions can be asked? Basically, ionic compound and covalent compound. Okay. Electrical conductivity of NaCl and CCl4. CCl4 is non-polar. Second here. CCl4 is non-polar covalent compound. Why? Even though there is a huge difference between the electronegativity of carbon and chlorine because of its symmetrical structure. This is very important point. Because of its symmetrical structure, net effect of electron pulls or net effect of electron negativity from all the four chlorine will be zero. Hence, there will be no formation of two poles. There is no delta plus delta minus here. Okay, therefore it is non-polar. So this chlorine is pulling electron equally opposite. Equally opposite. So there is no overall effect will be zero. Why HCl is polar? Here one is H, one is Cl. So Cl is pulling the electrons towards itself. So there is a slight negative charge and slight positive charge. So formation of two poles, it is polar. Ionic compounds have high melting point. So main important point, electrostatic force of attraction. That is a keyword. So we need more energy to break that bond, hence high melting point. Here, covalent compounds exist as gases, liquids, or soft solids. Again, you have to say here, not electrostatic, here, van der Waals force. Van der Waals force of attraction, which is very weak. So covalent compounds, the covalent molecules have van der Waals force of attraction, which is very weak. Hence, usually they exist as gases or liquids or soft solids at normal room temperature. Okay, this is the keyword. Comment your answers. First one. Two. Consist of molecules. Common characteristic of covalent compounds. Fine. Second one. Ammonium chloride. Next one. Again ammonium chloride. Okay. So ammonium chloride has all the three types of bonds. Let me tell you here, if you take NaOH, it will have covalent and ionic both. It's not only ionic. How? Na plus and OH minus, this is ionic. Within OH, what is there? Covalent bond, right? So this is covalent as well as ionic, sodium hydroxide. So like you have to check the formula. If you simply take KCl, then it is ionic. There is no covalent bond in that. Okay. Any ammonium containing compound has all the three type of bonds: ammonium chloride, ammonium sulfate, ammonium nitrate, all these.
Sir,
Yeah.
so but if they ask us what type of molecule is, like what type of bond, do we write ionic bond only for NaOH?
For NaOH, if the
If they
options
ask
are
what is the bond.
there, then ionic. If they give you question, then you can write ionic plus covalent, both.
Okay. But so if they ask what type of compound it is, then we can't write, then we write ionic compound, right?
Yeah, it is ionic. If metal is there, ionic only. Always remember, if metal is there, ionic. This is the last question. Again, mainly here, why I did not include other questions, because you will be asked only the electron dot structure. So you have to practice it.
So one clarification, if they ask us why non-polar covalent compounds are non-conductors of electricity, the main key term is that they don't have charged components.
Yeah, basically they don't have any free ions.
Yeah,
They
so
do
that's
not
all.
ionize in water, so they don't have free ions, so then they will not carry electricity.
So we don't need to mention about their solubility in organic solvents.
In organic solvents, not necessary.
Not necessary, right? Okay. Thank you.
Okay. Next, what we will take? Let's take some mole concept questions. Huh? Again here, mole concept we have to do. Okay, I'll just tell you what type of questions are coming, how to approach it. So definitions here, these three you have to work on: Gay-Lussac's law, Avogadro's law, and vapor density. Pakka definitions, what is given in your textbook. Final, last one time. Okay. Then these are the different type of questions which are asked previously. Basically, see, I taken only different kind of questions, so they not exactly same. Huh? To calculate the number of gram atoms in 4.6 gram of sodium. Remember, mole is same as gram atom. If you are asked to find the gram atom, just find the moles. Again, it is gram atom. It can also be gram molecule for the molecule. Okay. So what do you do? Mass by molecular mass. Mole is how you find mass by molecular mass. The atomic mass is given here. So for atom, it is atomic mass. So sodium 23, 4.6 by 23 you do. Right? You are getting 0.2 now. So this will be 0.2 gram atom. Simple question. Many children will have confusion. What is gram atom? Simple, mole only. Next, calculate the percentage of water. This one, so you're doing from 9th grade onwards. Now you should know it, how to do it. Okay, I think you will do it or practice. Next, this is a different kind of question here. Compound X and Y has the empirical formula X by 2. Vapor density is equal to its empirical formula weight. Determine
X2,
X2.
Y4.
So this they can also change. Vapor density is equal to 3 times of empirical formula, 2 times of empirical formula. So how you approach this? Simple. You know, vapor density is equal to X you take, and also it is equal to empirical formula weight. So empirical formula weight is also X, right? So next, to find the molecular formula, you need molecular weight. So molecular weight, how you find? 2 times vapor density. 2 times vapor density means 2 times X, right? Next, you have to find N. N is the number, molecular weight by empirical weight, right? Molecular weight is 2x, empirical weight is x. X cancel. So N is equal to 2. So multiply this xy2 by 2, you will get x2, y4. Any other question asked in the same way, you just do the same way. Okay, whatever they have given, you do it. Don't leave the question. I told you how to do it. Next, one question on stoichiometry. These are also very simple. In this particular question, they have already given you the molecular masses. So you no need to calculate them once again. And you see, they have not given any atomic masses here. Okay. So you have to rewrite the equation. I'm telling you the steps to get the full marks. So first you write the balanced equation. Then you write the question number 1. Step by step. What mass of aluminum hydroxide is formed from 12 gram of aluminum carbide? So you see, first you have to write the sentences. 4 moles of aluminum hydroxide is formed by 1 mole. Or because they have asked here mass, you can take the mass. You can take mole to mole ratio or mass to mass ratio. Okay. So Al4C3, 4AlOH3. So Al4C3 is 144 gram. If you take 144 gram of aluminum carbide, you will get what? 4 into. Do not leave the coefficient. 4 into molecular mass of AlOH3 is 78 grams. Right? Therefore, they are asking you, if you take 12 gram of aluminum carbide, how much you are getting? Simple cross multiplication you do, you will get the final answer. Okay, but you have to write the sentences, all of this. Second one is also similar. From 144 gram of aluminum carbide, we are getting how much volume of methane? Don't apply Gay-Lussac's law here. Gay-Lussac's law is only for gases. All the things should be gases. So here one is mass, one is gas. So you do not apply that. So 3 into 22.4 liters of methane. Therefore, 12 gram of Al4C3 will have how much? Simple calculation. Okay. So if you're not understanding in the exam, do step by step, you will get the answer, but don't do mistakes in the calculation. You know how to do, but doing mistakes in the calculation means, what, you will definitely lose marks. Okay. So this is another type of question. One more, based on the Avogadro's law here. Name the law if they ask you. So simply you will write the name of the law. If they ask you to state the law, then write the statement. Don't simply write Avogadro's law. Huh? So what is Avogadro's law? At the same temperature and pressure, equal volume of all the gases will have equal number of molecules. So based on that only they have asked the first question. If 150 cc of gas A contains X molecules, how many molecules of gas B is present in 75 cc? So if the volume is half, the molecules will also be half. So X by 2 molecules. Okay, these are very simple questions. Mole concept questions, na? Very simple. So Avogadro's law statement you have to check. This is last year asked. This is based on your Gay-Lussac's law. So how to write Gay-Lussac's law? First write the equation, balanced equation. Then you will write according to Gay-Lussac's law, step by step. I told plenty of times, but many children don't follow that. So then you have to see the question. So 2 volume of C2H6, 7 volume of O2, 4 volume of CO2. H2O you have to see. They have asked here room temperature. At the room temperature, water will be in liquid state. So for liquid and solid, volume we will take as 0. Means we don't consider them. These Gay-Lussac's law, Avogadro's law is applicable only for gases. So based on that, you calculate this. So if 80 ml of ethane is burned in 300 ml of oxygen, find the composition of the resultant gaseous mixture. Sometimes there is excess of reactant will be left. That also you have to check. Can anybody tell me what is the answer for this? Two volume, 7 volume, 4 volume. You're taking 80 ml of ethane. How much volume of CO2 you will get? 4. Double. 2 is to 4. 1 is to 2. Na? So 160 ml. 7. 2 is to 7. So calculate this. How much oxygen you need?
280.
280
80.
ml. Correct? Huh? Everybody?
Yeah, 280.
So then what is left here? See, actually they have given oxygen 300 ml. So there is some unused oxygen. That also you have to find. How much? 300 minus 280. 20 ml. So that is also in your gaseous mixture. So your gaseous mixture will have only 160 ml of CO2, 20 ml of unused oxygen. Don't write anything about water because they have asked it at the room temperature. You have to consider water if they mention above 100 degrees Celsius. Then you find water also because above 100 it will be gas. Okay. So be careful with this. This is last year asked. Okay. What is this? They will give you and ask you to find the molecular mass. Volume they will give you. Okay. So state the volume occupied by 40 gram of methane at STP if its vapor density is 8. So what is the use of vapor density here? They did not give you atomic masses. Na? So molecular mass you will get 2 times vapor density. So for methane it is 2 times vapor density, 8 into 2, 16. Right. So volume occupied by 40 gram of methane. So 1 mole of methane is 16 gram. It occupies 22.4 liters at STP. Therefore, 40 gram will occupy how much? Simple question. Hmm. Calculate the number of moles present. The number of moles is mass divided by molecular mass of NaOH will be 40. So 4 moles for the second one. Last type of question. Usually every year we have this question. Minimum for 2 to 3 marks. Okay. So step by step how to do this empirical formula and molecular formula. So always put the table for finding the empirical formula. Okay, and everything write clearly, neatly. Element, percentage, then atomic masses, third one. Then what atomic ratios? Next, simplest ratios. So step by step, neatly if you write, you will not lose any marks. Carbon, hydrogen, nitrogen. Then percentage, they will be given 75.92, 6.32, 17.76. Atomic masses also will be given 12, 1, 14. Then percentage divided by atomic mass, if you do, you will get atomic ratio. Okay. Then smallest number you will take and divide all the numbers, then you will get simplest ratio. Okay. But here, obviously, you don't have a calculator. So there you may do mistake. But I am using the calculator here to make it quick. So you will get here 6.32. This is also 6.32. 17.76. Two decimal points will be enough. 1.26. So out of these four, 1.26 is the smaller, right? This will be 5, this will be 5, this will be 1. So empirical formula is C5H5N. This is how you do it. In rare questions, you will have sometimes 1.5. Any one we will get 0.5. Then you have to multiply all the simplest ratios by number 2. Okay. Then you will make
So
the
if we get it like 1.49 or something, then are we supposed to round it off to 1.5 and then do it?
yes. Usually you will get near 1.5. Na? Always round it off to 1.5. Okay. Then only you have to multiply all the simplest ratios, not only that. So now you got empirical formula to find empirical weight. Then N. These are the steps. Remaining steps I told you previously, right? To find empirical weight, then find molecular weight is already not given. Vapor density is given. So multiply it by 2, you will get molecular weight. Okay. Then N you will find, then multiply it by same. For this, I think you will get the same thing. C5H5N only. Okay. So just do this step by step. So this is mole concept. Electrolysis. So here definitions what you have to work on is about strong electrolyte, weak electrolyte, non-electrolyte, and their examples. Most common examples you already know. Strong acids, strong alkalis, they are strong electrolytes. Weak acids like organic acids, they all are weak electrolytes. Even weak bases, ammonia solution is a weak base, calcium hydroxide is a weak base. Non-electrolytes are important. Distilled water, non-conductor of electricity. Kerosene, your alcohol. These are some examples of non-electrolytes.
Sir, liquid tetrachloride?
Liquid,
Tetrachloride?
yeah. CCl4 is also non-electrolyte, whether it is liquid or gas. Differences will be, basically they can ask you anode and cathode. Again, in bracket they may give you some with respect to this you have to write the differences, then you can. Okay. Ionization, dissociation. Anode and cathode, I will tell you simple technique. I told you many times. Remember NCR power. NCR power. N means negative, C means cathode, R means reduction. Cathode is negatively charged, reduction taking place, though it is a reducing electrode. This is also asked many times. Which electrode is reducing electrode? Cathode. P positive, A anode, O oxidation. Oxidation taking place at anode, so it is oxidizing electrode. Okay. Ionization dissociation, very important differences. Both, when you dissolve compound in water, you will get the ions in both the cases. But ionization is particularly for polar covalent compounds, which are not already in ionic state. Dissociation is for ionic substances, which are already in ionic state. Okay. So ionization definition will be formation of positive and negative ions by the compound which are not already in ionic state. Dissociation is simply separation of ions from the compound which are already in ionic state. Okay, differences. This is polar covalent, this is ionic. Cations, anions. Cat is positive, and is negative. One of the questions they asked, how they are formed from the atoms. To write the sentences when you're writing the differences, don't simply write positive ion, negative ion. Okay, these are the ions found by the atom when it loses electrons. Cation. Anions are when atom gains electrons, it will form negatively charged ion, which is called as anion. Metallic and electrolytic conductors. Or they can ask you differentiate between copper metal and copper sulfate solution. Okay, metallic conductor. So here plenty of things are there. Copper sulfate solution is electrolyte. Okay, so which are the conducting particles? Free ions. Copper metal conducting particles are free electrons. Copper sulfate, there is a chemical change taking place. You will get different products. Copper metal, there is no chemical change taking place. Okay, these are some two differences are enough. What type of questions can be asked on this? Mainly observation based questions. What is the observation at anode and cathode? So I have listed here molten lead bromide anode and cathode observation. I have included the question. We'll see that. So at anode you will get anion, means bromine is released, which is a reddish brown gas. Okay. At cathode you will get silvery gray metal. Remember, molten state only lead bromide, no aqueous state. It is not soluble in water. Acidified water, at anode what you will get? Oxygen gas. So you have to write the test for oxygen. Colorless gas which rekindles a glowing wooden splinter. Cathode, you will write test for hydrogen gas. Colorless gas which extinguishes a flame with a pop sound. Copper sulfate solution, there are two cases, right? One, if you use platinum anode, only anode matters here. Cathode, though, observation is same. In both the cases, what is copper? What is at the cathode? Pink metal deposit or reddish brown metal deposit. Or you can also say increases in the mass and size. But for platinum anode, if you take here, what is released? Oxygen gas. So again, write the test for oxygen gas. But if you take copper electrodes, means copper anode which is active, so you will get what? Copper ions are formed. So you have to write diminishes in mass and size. Diminishes in mass and size for anode. One more important point here about copper sulfate, when you take this here about electrolyte. What happens to color of electrolyte in this case? Platinum anode, if you take blue color, what happens?
Blue color, it's discharged. Yeah, color discharged.
Fades away, right? Yeah. But in case of copper anode, which is an active one, it remains same. Blue color remains same, unchanged. Now they may also ask you give reason for this. Okay, first point, what you will write? The blue color is because of what? Copper plus 2 ions in solution, electrolytic solution. So when you use platinum anode, copper 2 plus is converted into copper, but there are no more copper plus 2 coming from the anode. The blue color will disappear. But when you use copper anode, for every copper plus 2 converted to copper at the cathode, at the anode, you are getting back the copper plus 2 ion from copper. So overall concentration of copper 2 plus remains same, right? Therefore, the blue color will not change if you use active electrode. These are the observation based questions. Reactions, reactions, so usually you will write anode. One point you have to remember here, number of electrons must be equal. How many electrons are involved at anode? Same number of electrons must be involved at cathode. Why? Because whatever electrons are formed at anode, same electrons will be given at the cathode. You will not get electrons from anywhere else. Okay. So anode here, bromide, electron, it will lose bromine, so 2, 2, Br2. So same number of electrons here, Pb plus 2, 2 electrons, Pb at the cathode. If anybody having cathode and anode confusion, I told you, cat ions move towards cathode, cat. Anions move towards anode, plus and minus, you have to remember. Acidylated water at the anode, very important one, OH minus. So you have to show, multiply this by 4. 4 OH, okay, gives you 2 H2O plus O2. How many electrons involved here? 4 into E, 4 electrons. So write 4 electrons here also at the cathode. 4 plus 4 electrons, you will get 2H2. Then only you will get the ratio between these two as 2:1 by volume. So why the ratio between hydrogen and oxygen is 2:1 in water by volume is because every 1 volume of oxygen released at the cathode, at the anode, there are 2 volumes of hydrogen gas released at the cathode. Okay. When you write the electrons number same, then only will get it. For copper sulfate solution, again, if you use platinum anode, same reaction, whatever I have written here, same oxygen gas. Okay. If you use copper anode, so copper will lose 2 electrons and form copper 2 plus. Cathode for both same. Copper plus 2 will gain 2 electrons, become copper. Okay, so these are the reactions at anode and cathode. MCQs. First one. Yeah, good. Mainly ions. Second one. Act as a non-electrolyte. Yes, liquid carbon tetrachloride. Next one. Weak electrolyte is aqueous acetic acid. Very good. Next one. Both ions and molecules. Again, same question. Acetic acid. Okay. Fused lead bromide. What is the correct answer for this? 2 na, 3 na, 3 na. Silver gray deposit at cathode and reddish brown fumes at anode. Right. Next one. Which of the following takes place? Lead is deposited at the cathode, right? Lead is deposited at the cathode is the correct answer for this. Give reason I have listed here on this chapter. Sodium chloride will conduct electricity only in fused or aqueous solution state. So keyword here will be In fused or aqueous solution state only, it will have free ions which will conduct electricity. In solid state, they don't have any free ions. There are ions, but they are not free, so it will not conduct electricity. These are the keywords. Second one, electroplating. Okay, electroplating of nautical silver. The electrolyte sodium argentocyanide solution is preferred over silver nitrate solution. So silver nitrate solution, if we use, you will write deposition is fast, hence not smooth. Okay. Although copper is a good conductor of electricity, it is a non-electrolyte because it has no free ions. The conducting particles are free electrons. Therefore, it is a non-electrolyte. Copper metal is a non-electrolyte, remember. Next one. During electrolysis of molten lead bromide, graphite anode is preferred because it is unaffected by reactive bromine vapors. Bromine vapors. And remember, children, we are having the temperature of around 380 degrees Celsius here for this one. Electrolysis of molten lead bromide is considered to be a redox. All electrolysis reactions are redox, not only this. Why? Because at anode, PAVO means oxidation is taking place. At cathode, reduction is taking place. So both are taking place simultaneously. Hence, we call it as redox. Some questions on selective discharge of the ions. Okay. Cations, so you know. Anions, remember, suno caliber ayu. Suno caliber IO. Decreasing order. Which is bottom, that will discharge faster. Okay. Suno caliber IO. You can write whatever way you want. Chalo, A. What is your answer for this? Copper plus 2. Copper is below hydrogen, na? In the positive, if you take cations list. B. See, most readily they have asked here. Sometimes they can change the question as least readily. So be very careful. B. Electrolytic reaction. Okay. Platinum. C. Using copper electrodes as anode. Okay, here nothing is discharged actually when you are using copper metal, right? It is active electrode. Now, what is the product form we can say? Product form will be copper plus 2. D. Most readily cation H plus. Simple. During electroplating of an article using potassium argentocyanide as an electrolyte, the anode material should be Ag.
So for the D question, instead of dilute sodium chloride, if it was fused sodium chloride, then the answer would have been Na plus.
Yes.
Thank you.
Fused means there will be no water, na?
Yeah.
And here, remember children, dilute NaCl is simply electrolysis of water only. Electrolysis of water only means products will be oxygen and hydrogen only. If you use concentrated NaCl solution, only the product at the cathode will change. So what is a product at the anode? Okay, sorry. Product at the cathode remains same, hydrogen gas only. No sodium will be formed at cathode. But at anode, you will get chlorine. This is the effect of more amount or more concentration of chloride ions. So concentration is one more term which will affect the selective discharge. So only in this case, only this change will be there. But in both the cases, hydrogen only will be released. Okay. Electroplating here with silver and with nickel, you know what is the electrolyte we are using. Okay. always write the aqueous solution first, because many times you're writing the name but you are not writing the solution. So start with aqueous solution only. Aqueous solution of sodium argento cyanide. Aqueous solution of nickel sulfate. Okay, here anode will be the pure metal. What metal you want to deposit now? That. Cathode will be the article to be electroplated. Article to be electroplated. So you can also check the definition of electroplating. So based on that same question, electrolyte used is sodium argentocyanide solution. Okay, then again same question, the electrolyte used for electroplating an article with silver, sodium argentocyanide solution, or you write aqueous solution. Give one word. Electrolytic deposition. This is the electroplating definition. Simple definition you can remember. Using electricity, you are depositing a superior metal on the baser metal. Picture studies on this will be simple if you know all the things what we discussed just now. Okay. Which electrode to your left or right is known as an oxidizing electrode, and why? So comment which one, left or right? This is oxidizing electrode. See here, this is plus, this is minus. NCR power, remember this. Where is oxygen? At the anode. Oxidation is at the anode. So left positive is anode, na? Add anode. Negative is cathode. So what is our left? That is that one is oxidizing. Why? Because there is oxidation taking place. Or you can explain it. Write the equation represent the reaction that occurs. So we discussed this. Observations also we discussed. Last question on electroplating. Name the electrolyte. The aqueous solution of nickel sulfate. Name the cathode. Name the anode. Anode will be the pure nickel plate. Cathode will be the keychain here. Okay. Reaction is simple. Cathode, what is happening here? Cation. Cation is nickel. Gains 2 electrons and deposits as a nickel metal. Anode will be the same nickel will lose 2 electrons and form nickel ions. So this you can also write like this. Nickel gives you nickel plus 2 electrons. Both are same. Okay. Same for silver also. At the cathode, cation is Ag plus. It will accept 1 electron. Silver is deposited. At the anode, silver is losing electron and forms Ag plus. Last part here will be one more purification of impure copper. So impure copper, thick block of impure copper you will take as anode. Thin sheet of pure copper you will take as cathode. Pure copper. So this is cathode, this is anode. Reactions are same what you learnt in electrolysis using copper electrodes. So here copper will lose electrons and form copper plus 2. Copper plus 2 will gain the electrons back and become copper. In this whole process, whatever impurities are formed, impurities deposited at the bottom near the anode, we call it as anode mud. What do we call? Anode mud. Okay. So this is all about electrolysis. I have not included many questions because I already told you what type of questions that can be asked. Okay, next what we will take acid bases. Some important points in acid, bases, and salts. Okay. Acetic acid has 4 hydrogen atoms, but its basicity is 1. Because only one hydrogen atom which is attached to oxygen is replaceable. Phosphorus H3PO3, phosphorus acid, basicity is 2, even though there are 3 hydrogen atoms. Why? Because it will give you only 2 hydronium ions when dissolved in water. All the acids will give you what? Hydronium ions in water as the only cation. No other cation should be there. Silicic acid, this is very rare, but you know, H4SiO4, basicity is 4. 3, you can remember H3PO3, right? Phosphoric acid. Weak mineral acid or mineral acid which contains carbon in it. Anybody? What is the name of that?
Carbolic acid.
Carbonic acid. Carbonic acid, even though it is a mineral acid, it is weak. Okay, this is H2CO3. Again, what is the basicity of this? 2. Indicators. Okay, simple technique to remember if you're having confusion. Phenolphthalein is pink only in alkali or base. In all other cases, it is colorless, neutral or acidic. Methyl orange, remember POY, POI. Pink, orange, yellow. Pink, left hand side means acidic, orange neutral, right hand side yellow means basic condition. In the basic condition, it will be yellow. If you remember this, you will not have any confusion. So what we did not cover in typical acid reactions of HCl, H2SO4, HNO3 and acetic acid, all of these we are covering here. Simple. So acid with metal, you will get salt plus hydrogen gas. With all of these except dilute HNO3. Because dilute HNO3 is a very powerful oxidizing agent. It will oxidize hydrogen to water. Therefore, we can get hydrogen only with Mn or Mg, manganese or magnesium, with very dilute, remember, not only dilute, very dilute HNO3. You can say 1%. Gives hydrogen gas. In all other conditions, it will give you water. This is only exception. All other reactions are same. Next, with base, so neutralization, salt and water. With carbonate or bicarbonate, you will get respective salt plus water plus CO2. Sulfite or bisulfite, again salt plus water plus SO2. Metal sulfide, only salt and hydrogen sulfide. So for every gas, you should know the test. CO2 turns lime water milky, has no effect on acidified KMnO4 or potassium permanganate. SO2 turns lime water milky and changes the color of potassium permanganate from pink to colorless and potassium dichromate acidified from orange to clear green. H2S turns moist lead acetate paper silvery black or simply black. So what happens here? Lead and sulfide both will react and form lead sulfide, PBS, which is black precipitate. Okay, so these are the reactions and tests. No need to remember separately. Any compound with any acid, general reaction. Come to bases. In that we have soluble bases. What are alkalis? They are soluble bases, soluble in water. So in that you have to remember which are strong. NaOH and KOH. Only these two are strong alkalis. Or, sorry, group 1 metal hydroxides. They are also strong. Lithium hydroxide, Sodium, potassium, rubidium, all these hydroxides. Weak are ammonia solution, NH4OH. All of these obviously in aqueous state, not in solid state, that you know now. And calcium hydroxide solution. These two are weak alkalis. This is very rare, but in your specimen question paper, they have asked one of the questions on this. So I have included here. Types of oxides we learned in lower grade. Huh? Acidic, basic, neutral, and amphoteric. Acidic oxides are usually non-metallic oxides like CO2, SO2, NO2, right? Basic oxides are usually metal oxides, right? Copper oxide, calcium oxide, or hydroxides. Neutral are carbon monoxide and water. You remember only these two. Even NO is also neutral. Single oxygen atom. CO, H2O, NO. Single oxygen atom. Amphoteric are three metals you have to remember: zinc, lead, and aluminium oxides and hydroxides. These are amphoteric.
So what is SiO2?
SiO2 is a non-metallic one, so it will
Okay.
also give you acidic
Okay.
oxide.
Thanks.
So
So SiO2 is an impurity, right, in some place?
maybe if we don't want it, it will be impurity. If we want it, it will be our main compound.
Uh,
SiO2 is usually silica, so earthy impurity. If you're extracting some
oh,
metals,
sir, it was given in a textbook, like some metal
Yeah,
was
in,
being.
in Bayer's process, amphoteric, non-amphoteric one.
Oh, right. Yeah.
so here these are amphoteric, means they will react with both acid as well as base depending upon what you are adding. Okay, so if you're adding acid, they will act as a base. If you're adding base, they will act as an acid. Huh. To give your answer for this one, pH scale. Alkali. So I hope you know already simple pH scale 0 to 0 to 7 and 14. So this range is acidic, this range is basic or alkaline. Okay. If you want to increase the pH, you have to add the acid, alkali. Sorry. If you want to decrease the pH, you have to add the acid. One more, just know here, universal indicator. Universal indicator gives us different colors for different pH values, unlike the litmus paper. Litmus only red or blue, like that. Right? Universal indicator is a mixture of different organic compounds, organic dyes. So how to remember it? Remember Vibgyor in the reverse order. R you can also change by pink. Okay, red or pink, similar. So green is there now. This one you can say that pH is 7, means neutral. After this, whatever these three colors are there, they will be alkaline or basic. These three, Roy, this will be acidic. Only for universal indicator. Very rare question, but if they ask, you should be able to. And it is easy to remember also. Vibgyor, you have to write reverse order. Chalo. Next one. Will not produce an acid when made to react with water. Carbon monoxide. You know it because we discussed it just now. So remaining three will be acidic oxide. Acidic oxide so will give you acid. This is neutral oxide. Next, complex salt. Tetramine copper 2 sulfate. This is the inky blue solution. Inky blue solution. Analytical chemist will see. The metal oxide which can react with acid as well as base or an alkali.
So what type of salt is iron to ammonium sulfate?
We call it as double salt, where
Okay.
there are two cations and only one anion.
Yeah.
Okay, aluminium oxide. Fine. Scientific reason here, I got only one kind of question here, but you can say based on basicity, acidity. You can guess it. Huh? Electrical conductivity of acetic acid is less in comparison to electrical conductivity of direct sulfuric acid. Always, children, write first whether it is strong or weak. First, you write it is a weak acid, partially dissociates, okay, and have less number of ions. Less number of ions. Now, for dilute sulfuric acid, you will write strong acid, completely dissociates, has more number of ions. Which ions we are talking about? Hydronium ions. Okay. So conductivity depends upon the concentration of ions. More the number of ions, more will be the conductivity, or better will be the electrical conductivity. Less means less. Okay. So these are the points you have to write. They can change the acid names. Acetic acid with respect to dilute hydrochloric acid, dilute nitric acid, or formic acid with respect to this. So same answer only. Okay, this is another different kind of question. Based on your knowledge about the reactions and all, solution A, solution B. Okay, what is answer for A? Which liberates sulfur dioxide from sodium sulfite? You have to write the solution, don't write the compounds. So solution C is dilute sulfuric acid. Yes. What about B? Give a white precipitate with zinc sulfate. A, sodium hydroxide. Very good. That's the analytical chemistry part. No? So what is left? CAB. B, what is B? Weak acid. So answer is that. Now come to important part. Salts. Salts method of preparation, especially. Here, don't worry about the procedure, anything. Equations and the names. We need only these two. So, I think after discussion of this, you will have no confusions left. So here see, FeCl3 always first check if there is a ferric chloride. Direct combination. Always. Direct combination. So Fe plus Cl2 gives you FeCl3. This you have to balance. 3 here, 2 here, 2 here. So this is always direct. This is the most asked question. Direct combination, or you can say synthesis reaction. Synthesis also. Coming to what are the different things, I will explain it. Then you can go. Remaining questions. Second one, simple displacement. Usually we know metal plus acid. That only you will get. So active metal you have to take, like zinc. Okay, with any acid like chlorine if you take, HCl if you take, zinc chloride, zinc sulfate if you take, or you can take the magnesium chloride, magnesium nitrate, magnesium sulfate. So these all will be simple displacement. Third one will be double decomposition. In this you have two types, if you remember. One is precipitation, another one is acid base, acid plus base. So here precipitation, so usually you have to remember the most of the carbonates, they are precipitates, like lead carbonate, zinc carbonate, calcium carbonate, these one. Apart from that, you know, lead sulfate and lead chloride, they are also precipitates. These are the most commonly asked precipitates. Then acid base, if you come, here it depends upon what base you are using. If you are using alkali, which is a soluble base, then that particular reaction you call as titration. If you use acid plus alkali, if you use acid plus insoluble base, then it is called as neutralization. When you have both the options, neutralization, titration, Then you have to check for the alkali. Okay. Sir, how to know which are insoluble bases? I already told you which are alkalis. Only four you remember. Sodium hydroxide, potassium hydroxide, ammonia solution, calcium hydroxide. Apart from these four, whatever else is there, they are all insoluble bases. Okay, simple to remember. Now here match the column. Lead nitrate. Nitrate, what I told you previously, all metal nitrates are soluble. All metal nitrates are soluble. Means it is not a precipitate reaction. Right? But from PbO, PbO is what? Metal oxide. Metal oxide is a base. And it is not a soluble one. It is insoluble. Then, which is that? Neutralization should be there. 3. Right? This one to 5 you put. Magnesium chloride from magnesium. Magnesium is active metal. Magnesium chloride is a solution. So what you will get? Simple displacement. Metal you put in HCl. NaNO3. All sodium. One more point you can mention here. All sodium and potassium compounds are soluble. So you will never get any precipitation reaction for sodium or potassium compound. Usually it will be titration.
Even ammonium compounds are soluble, right?
Yes, ammonium compounds are also soluble. So here for this one you will write titration because NaOH is a alkali. Last one is what is left? Precipitation. Zinc carbonate. I told you these carbonates are usually precipitates. So that one you have to match here. Fourth. Okay. This is how you have to remember this. So this is just to match the column. They can also ask you to write the equations like this. This is also match the column only. So you have to name the method used for preparation of the following salts. Now come to sodium nitrate. Sodium compounds are soluble, nitrates are also soluble, I told you. So it cannot be precipitation. Precipitation is not given also here. Fine. What is the match for this? Which one is the match for this? Comment. Yeah, somebody want to tell? Yes.
Sir, 3.
3. Decomposition by acid. No.
Sir, it's technically titrations or neutralization.
Yes. Neutralization. Because there is no titration given here. So then it's obviously neutralization only, na? Acid plus base. What I told you, if there is titration as well as neutralization, then only you check for alkali and insoluble base. Otherwise, directly the acid base. Second one, iron 3 chloride, so we just know it. Fifth one, direct combination. See, what is lead chloride?
Simple
Third.
displacement.
Simple
Third one.
displacement cannot be because lead chloride is a precipitate.
Decomposition.
So third, decomposition by an acid.
Yes. No, not.
Sir, double decomposition.
Yeah, double decomposition.
Decomposition.
Precipitation, na? So it is double decomposition. Zinc sulfate will be what? Simple displacement.
Simple displacement.
So 1, 2, 3 is left. So how sodium or hydrogen sulfate is the decomposition by acid? So how do you get it?
Sir, non-volatile acid, that is
So lab
sulfuric
preparation.
acid dilute
Yes.
under 200 degrees Celsius, so you get the
Yes.
acid salt.
So you are
So it's
breaking
lab
an acid
preparation.
using lab preparation using acid. So therefore it is called as decomposition by acid. Sometimes you see out of 5 you may not know one question, not at all, no idea at all. Then remaining 4 when you know, obviously you will get the fifth one automatically. Find the odd one out. Answer.
Hydroxide.
Which one?
Magnesium hydroxide.
Remaining 3, see, explain your choice. Remaining 3 are amphoteric oxides or hydroxides. This is a basic.
So over here, can we give zinc hydroxide and the rest are insoluble?
Zinc hydroxide is also not soluble, no? You will get white precipitate. Aren't it? Zinc sulfate plus NaOH. When you do, what you will get? Zinc hydroxide. White precipitate only.
But isn't it soluble in excess?
But that is not the thing here, no?
No, but can we write that? That in excess it's...
Then,
Yes,
do
sir.
you know about magnesium hydroxide, whether it is soluble in excess or not?
So it's
No,
insoluble.
sir, it's not
And what
soluble in
about
acid.
aluminum hydroxide? That is also not soluble or soluble.
Other three are insoluble in excess.
Zinc hydroxide, again, it depends. Better way will be simple one will be okay. What is the nature?
Yeah, I understood this way, but the other one, can we do that or it's
I don't, prefer it.
okay?
This is again different kind of question that can be asked. So they will simply put the arrow marks. So this is starting material. This is your product. So you have to write the 5 equations for 5 marks. So what is equation A, B, C, D, E? Okay. So again for this you should have the knowledge of the what type of reactions they are undergoing. What is the cation and anion? So see, I tried to tell you, but I don't know how much you know it. See, zinc sulfate you have starting material. So you want a zinc carbonate. So definitely you want carbonate. Then other substance must be there which contain carbonate. And previously what we have knowledge, carbonates are precipitates, most of them. So it should be precipitate. Then you can take sodium carbonate which is also soluble. This is a precipitation reaction. What you will take? Two aqueous solutions plus Na2SO4. Okay. So this is how you have to understand this. B. How do you convert zinc carbonate say zinc nitrate? This is so direct.
HNO3.
Yeah. You can add HNO3, then your products will be different. You can also add sodium nitrate, then your products will be different. So dilute HNO3 if you add zinc nitrate plus H2O plus NO2. You have to balance all of these. Just don't write the equations. Okay. C. Zinc nitrate is zinc hydroxide. So to this what you will add here hydroxide. If you want to get NaOH you can add.
Sodium hydroxide.
Yeah.
Sir, can we add KOH?
KOH also you can add. Plus NaNO3. Now zinc hydroxide say zinc oxide, how do you get?
Sir, CaO?
CaO.
Thermal
If you add
decomposition.
no. CaO if you add you will get different
Can we do
product.
thermal decomposition for?
Yeah. You can simply heat it. Just like aluminum hydroxide you heat na.
Sir, why will we get a different one with CaO?
Because ZnOH twice is amphoteric in nature na. So it's just like when you add sodium hydroxide you will get sodium zincate na. Here you will get calcium zincate.
Ah, okay. Sorry,
Right.
got it.
So this is simple thermal decomposition you can do plus H2O you can get. Right. Just like the third step in Bayer's process, LOH thrice heating, Al2O3 plus H2O, same thing. ZNO now, base, you want to get zinc sulfate, add the acid, sulfuric acid. So you will get the salt plus water.
Sir, for the A part, why can't we add H2CO3?
H2CO3 is a very weak acid and it may not be having more number of H plus ions or carbonate ions. Because it is a gas usually, CO2 gas dissolved in water, it will keep on escaping.
Okay, got it.
But you can also add ammonium carbonate if you want. Ammonium carbonate is also soluble in water. But see, children, if you're not confident about these kind of questions, then better choose the different question in the exam. Okay. Chalo. Analytical chemistry will quickly take. What is left now? Analytical chemistry and metallurgy. Only these two, na?
Sir, are we doing it separately for practical chem?
Practical chem will take some questions. Analytical chemistry is very simple. Here you just will get balanced equations, observations, what is the precipitate, what happens in excess, these kind of questions only. Okay, to make it simple, see what are the ions you have to know. 6 ions, Zn plus 2, Ca plus 2, Pb plus 2. These are colorless, means they will give you white precipitates. Copper plus 2, Fe plus 2, Fe plus 3. These will give you colored precipitates. Copper, pale blue precipitate, ferrous, dirty green, ferric, reddish brown. These three white precipitate. If you know which is gelatinous, which is chalky, fine. Otherwise white is enough. Okay. Now metal ions whose precipitates are soluble in excess of NaOH solution. Out of these six, if you take Zn plus 2 and Pb plus 2, initially you will add NaOH, you will get white precipitate in both the cases. Then you will add excess, then both will be soluble. So that's what I'm telling here. I'm just writing the ions. Okay. Ions means you should know it is zinc sulfate or zinc nitrate, lead nitrate, these compounds. Okay. Second one, metal ions whose precipitates are soluble in excess of aqueous ammonia. So zinc is common in both the cases. One more is copper ions. Copper, pale blue precipitate in excess, dissolves and forms inky blue solution. Remaining all will be insoluble. The metal ion which does not form precipitate with aqueous ammonia solution out of these six is calcium. Calcium will not give you any precipitate with aqueous ammonia. Okay, no need to remember them separately. I am trying to club them. Next, ammonium salt heated with alkali gives you dash gas. You know already this is a method of preparation of ammonia gas. But in the exam, if it is asked in the give what is this like this fill in the blanks and all, you will sometimes don't write the correct answer, huh? Or name the gas. So this will be ammonia gas. Ammonia gas. Inky blue solution formula. Inky blue, we don't know, but I'm just telling you. It may be asked. NH3 4 outside SO4. What is the name? Tetraamine. AMM. Okay. Copper 2 sulfate. This is the name. So here with NaOH and KOH, hot and concentrated. This is the second part. Precipitations are over. Now these two with three elements, zinc, aluminium, and lead. So they will ask you write a balanced equation when zinc reacts with concentrated NaOH. So we know metal plus acid, but we don't know metal plus base. So this is it. Here also you will get hydrogen gas. Okay, but the product, one more salt is soluble salt. All these are soluble salts, and all of them are colorless. This is sodium zincate Na2ZnO2. For aluminium, remember you also have to in the reactant side write plus H2O. Otherwise, you will not be able to balance it. Only for aluminium metal. Then you will get sodium aluminate. For lead, sodium plumbite. Plumbite. Anybody have difficulty in remembering the formulas? Easiest way is in all the cases NaAlO2, sorry. In all the cases O2 will be there na. So O2, if you take minus 2 into 2, minus 4 overall charge. To balance this you should have plus 4. So zinc you have. Zinc, what will be the valency? Plus 2. So another one more is sodium. Sodium will have plus 1. Therefore, overall 4 you have to get means you have to take 2 sodium atoms. Na2ZnO2. Same for lead. But for aluminium, what you will have? Al plus 3 is there. Then only 1 sodium is enough. In sodium aluminate, you will have only sodium, 1 sodium atom. Simple mistakes you will do in the exam. Formulas and all. So this is a technique you remember. What gas is released? Hydrogen gas. The same metal oxides and hydroxides which are amphoteric, this is neutralization. It can be NaOH or KOH. Wherever Na is there, K you replace it. So same salts you will get. Same salts plus water. Not hydrogen gas, plus water. Okay. Okay. Comment your answers for the first one. A chloride which forms a precipitate that is soluble in excess of ammonium hydroxide. Excess of ammonium hydroxide, yes, copper chloride. This one second, hydroxide of this metal is soluble in sodium hydroxide solution. Lead means they have already have lead hydroxide which is soluble in excess of sodium hydroxide. C, pale green precipitate means dirty green only. Second one, iron 2 sulfate. See, we have seen for sulfate, barium chloride will give you barium sulfate, which is white precipitate. Relevant observation, sodium hydroxide solution on ferrous sulfate solution. Here they did not mention any excess of sodium hydroxide. So simply you will write dirty green precipitate. Don't write anything extra. Huh? Dirty green precipitate formed. Even don't write action of sodium hydroxide solution on ferrous sulfate solution gives you dirty green precipitate. Just directly write the answer. Save your time. Okay, this one. See here, they have asked you to identify the cations. They have given you observation, so you have to write the cations. Don't write the formulas. Names you have to write. Okay. So what is the first one? Anybody?
Fe3 plus, it will be ferric ion.
Ferric. You can write ferric, or you even if you write iron in bracket 1, 2, 3 iron, that is also correct. Okay. What is the next one, children? Gives white precipitate which does not dissolve in
Lead ion. Lead ion.
lead. So only lead and zinc will give you, calcium will not give you. So it is lead in bracket, right? 2 iron. Next, NaOH solution when added to solution C gives you white precipitate which dissolve in excess.
Calcium ion.
Yes, only calcium will give you this. Zinc and lead both are soluble. Okay. This is again give a balanced equation. Balanced equations so simple, but this is for zinc is heated with sodium hydroxide, zinc oxide with sodium hydroxide. This is what I recently told you, sodium zincate plus hydrogen. Okay, sodium zincate plus waters. This is hydrogen you will get here, water along with sodium zincate. Okay, this is done. Okay. So this is about metallurgy. The definitions you have to see is what are minerals and what are ores. So simple way, ores are also minerals, but from these are the particular minerals from which you can extract the metal with low cost and less effort. Okay, so that particular mineral you call as ore. And what are the impurities present in them? In all of them, or the impurities we call them as gang. Check the spelling, not Gang, Gangue. Okay, remember important ores of aluminium, iron, and zinc. There are 3 ores of aluminium, 4 of iron, 3 of zinc. Main ore, I'm just telling you, main ore of aluminium is bauxite, iron is hematite, zinc is zinc blende, which is ZNS. Okay. Next, if you come to concentration methods, okay, here mainly you have 4 methods, but I have included 3. Last one is chemical method or leaching. Hydraulic washing, what is the principle you have to remember? It depends upon the density difference between the gang and the ore particles or the metal ore particles. Example of this, oxide of iron. One example you remember, oxide of iron like hematite ore. Magnetic separation, so you know one is magnetic, another one is non-magnetic. Example you remember, tin stone from magnetite. Tin stone is what? SnO2, tin oxide. Magnetite is Fe3O4, one of the ore of iron. Fe3O4, not Fe2O, Fe2O3. That is different. Ferric and ferrous different. This is Fe3O4. Froth flotation, preferential wetting. So what happens here? Froth flotation, you will have two layers. One is oil layer, another one is water layer. So the ore, which ore we are concentrating here? Sulfide ores, zinc sulfide or lead sulfide. Ore is preferentially wetted by the oil, and gangue preferentially wetted by the water, and then they will pass the air, froth will form, then they will remove the froth which contains the ore. Okay, so here important point here, froth flotation, many children will write, many times I have seen, name the following, the concentration method for the sulfide ores. Many of you write roasting. Roasting is not the concentration method. Concentration method means what? Removal or purification. Roasting is a chemical. This is just a physical process, no? Huh? Roasting is chemical method. Zinc sulfide say zinc oxide you are converting. That is not concentration. Okay. Here, roasting and calcination differences you should know.
So for that concentration of ore, if we get a question saying what is the method of concentrating bauxite, what are we expected to write?
Chemical method.
Can we write Bayer's process for that?
The process name they ask you, then it is a Bayer's process.
Okay.
Yeah. Because we have specific name for it, no?
Yeah.
The chemical method or leaching is a general term.
Okay.
Roasting and calcination, in both the cases, we heat the ore to a high temperature. But in roasting, we do it in presence of excess of air or sufficient amount of air. And this is in absence of air calcination. Means air is not necessary for them. Why? Because roasting is done for S. S means sulfide ore. Means they don't have already oxygen. What we are doing here, these are conversion of ores into metal oxides. Right? Zinc sulfide say zinc oxide you want to do. So you need oxygen. So that you will get by air plus SO2. But for calcination, they already have oxygen in the form of C. C is what? Carbonates. So carbonate ores are done calcination. So you will see calcium carbonate, if you simply heat them, calcium oxide and CO2. They don't need any external oxygen. Same for copper carbonate. Okay, simple. S for sulfide, C for carbonate. Reduction is important here. To understand reduction, next stage, na, we have different stages. Next stage, reduction. Here I have classified the elements, their oxides, according to their reactivity, based on reactivity series. Highly active metals, their oxides, you want to do the reduction. Reduction, what we do, we take metal oxide and reduce it to respective metal. That's what we are doing in metallurgy, na? Extraction of metal. We can't use any reducing agent. What are the three reducing agents we are using common? Hydrogen, coke, means carbon in the form of coke, and carbon monoxide. These are the common reducing agents. But we don't use them for the first group. Why? Because they have strong affinity towards oxygen. You can't, or these things can't break the bond between oxygen and these metals. So we can do only electrolytic reduction. Therefore, Hall-Herold's process we do for aluminum oxide now, right? Because it is highly active metal. Second one, moderately active. For them, you can use hydrogen, coke, or carbon monoxide, any three. One exception you should know. For zinc oxide to zinc, you can use only coke. Hydrogen and carbon monoxide are unable to reduce the zinc oxide to zinc. Only coke can do. The temperature we are keeping here 1400 degrees Celsius. So what is a C plus OCO you will get byproduct. Okay. So this is one important point in reduction. Last one, very weak or least reactive metal oxides if you come, even you don't use any or no need of using any reducing agent, you simply heat them. HGO or AGO, if you simply heat them, they will decompose into respective metals. Okay, plus oxygen. These are the three categories in reduction process. Alloys, 2 marks minimum will be there, definitely. So now how to remember them? I will tell you how to remember the elements present in them. Uses part, so you have to read many times. Duralumin in the order, higher percentage is aluminium, then copper, then magnesium, then manganese. To remember, alku Maggie man. Stainless steel, Facronic, iron, chromium, nickel, and carbon. Decreasing order of their percentage. The main element will be whatever we are writing at the first. Aluminium for duralumin, iron for stainless steel. Brass, so right? Copper and zinc. Copper plus tin plus zinc for bronze. But main elements are copper and tin for bronze. Small amount of zinc will be there. Solder is 50-50 of solder S tin. LD is lead. So tin and lead 1:1 ratio. Okay. So these are the 5 alloys you should learn. Uses, as I told you have to read. Huh? Most common uses for duralumin is aircraft bodies, stainless steel is surgical instruments, brass decorative purposes, electrical goods, bronze mainly statues, medals, coins, solder is for soldering purpose or fuse metal. It's also known as fuse metal. Okay. Bayer's process, you have to practice the equations. 3 equations are there. Huh? Starting material, products with conditions. Can anybody tell me what is the first step in Bayer's process? What do we do?
Al2O3
Hmm?
dot 2H2O
Yes.
suboxide plus NaOH concentrated,
Hmm.
and then you have to heat it,
Mm-hmm.
and you will get
What's the temperature we are keeping? 150 to 160?
150 to 160, yeah.
Okay.
And then NaAlO2, so sodium aluminate, plus water.
Okay. So this is the equation, you can balance it. Fine. See children, this is very easy to remember because if first you remember this, bauxite, so you remember hydrated aluminium oxide, right? So then you just take sodium aluminate and water only in the next step. NaAlO2 plus H2O excess, right? Excess you write. Temperature you reduce 150, say 50 you do. Then you will get aluminium hydroxide. Plus what else you will get? Sodium hydroxide. Whatever starting material you took, na? 3 are common only. What are the 2 products you return as reactant? One reactant you return as product. ALOH thrice is a new thing. Then aluminium hydroxide you take, heat it around 1100, you will get aluminium oxide plus water. This is our aim, to get the aluminium oxide from bauxite. So it is so simple. See, if you just heat bauxite ore, you will get aluminium oxide. Why we are doing 3 steps, right? Because this is the concentration, means we want to purify the ore. So what happens when you use, what is the role of sodium hydroxide here? Aluminium oxide is amphoteric, sodium hydroxide is basic. So it will react with it and form salt and water, which is soluble. There are some insoluble impurities formed. Which we call as red mud, which will be removed by filtration. If you simply heat bauxite, it is not purification. Then sodium aluminate is solution. So you want to get back the solid, that too in the form of Al2O3. So you will do 2 more steps. Okay. Definitely aluminium extraction. Definitely you will have 3 to 4 marks guarantee. Huh. A bronze main element metals. Fourth one, copper and tin. Okay, Kutin. Chalo. B, not an alloy of copper. Duralumin we have na alku megi mein. Alku, who is there? Okay, for the B you are writing. Not an alloy of copper. 3, solder. Only tin and lead. Remaining 3 will have copper. This one is what? Alku megi main. MgMn. Okay, main ore used for the extraction of iron. This one so easy. Hematite. Huh, this one who knows? It is a strong reducing agent. Very good. So the reaction is aluminium plus Fe2O3 gives you Al2O3 plus Fe. And this is highly exothermic reaction, so that whatever iron is there that is in liquid state you will get. So that is used for welding purpose. Metal in liquid state. Okay. Next, zinc and tin. 3, bronze. Right. Okay. Which of the following metallic oxides cannot be reduced by normal reducing agents? Interesting question. Correct, correct. You can't reduce magnesium oxide because it is highly active. Okay, brass is an alloy of copper and zinc. That's fine. Come to Hall-Herold's process. This is for what? This is reduction. Metal oxide say you want to get the metal. So Al2O3 say you want to get Al. Okay. Sure. These are the common questions you will get. The role played, what are the electrolyte mixture and all. So let me explain. First, usually when before Hall-Herold's process was discovered, the temperature for this method was 2050. Okay. So Hall-Herold were doing plenty of different kind of experiments. One fine day they found that if you take the mixture of alumina, cryolite and fluorspar in the ratio 1 is to 3 is to 1, means 20%, 60%, 20%. Then you can reduce this temperature to only 950 degrees Celsius. What was the difficulty? One, this is a very high temperature. At this temperature, whatever aluminium formed was in a vapor form. So how do you collect a vapor? Right? But at the 950 degrees Celsius, whatever aluminium you will get, that will be in a liquid state. Okay. Because cryolite is in more percentage, you can say it is acting as a solvent here. Here you are not using any water. All of these are in molten state. All in molten state. Cryolite formula, many times that is also asked. Cryolite formula is Na3AlF6. Fluorspar is calcium fluoride, CaF2. Alumina to Al2O3. Now, come to here, role played by cryolite. It lowers the fusion temperature. Lowers the fusion temperature. This is the main role played by it from 2050 to 950 degrees Celsius. If they ask you cryolite role, this only you write. 1 point. For 2 points, then write enhances the conductivity also. Otherwise, they will also ask you what is the role played by fluorspar. You write increases or enhances the conductivity for this. Sodium hydroxide. This one they have asked overall extraction of aluminium means it includes Bayer's process as well as Hall-Herold's process. Sodium hydroxide, I just explained, it is used to remove the impurities by forming a soluble sodium aluminate salt. Graphite here will be used as anode. Graphite is anode. The electrolyte is covered with powdered coke. This one is asked many times. 2 points. One, it prevents burning of what? Of anode. Second one, reduces heat loss by radiation. Okay, these 2 points you remember. One, prevents burning of anode. Second one, reduces heat loss by radiation. Which one? Powdered coke, which is sprinkled over the electrolytic mixture. It acts as a blanket, you can see. Name the other aluminium containing compound added to alumina and state its significance. Cryolite, we just discussed. Give the equation for the reaction that takes place at the cathode. We'll see. Explain why it is necessary to renew the anode periodically. Okay, so it depends upon the reaction. So cathode, what is happening? What is cathode we are using here? Anybody? What cathode is made up of? Anybody?
The graphite lining of the thing? Electrolyte?
Gas carbon?
We call it as gas carbon lining. Both are made up of carbon only, but the cathode is gas carbon lining. Gas carbon is again one of the allotropic form of carbon. Anode will be again made up of carbon, but it is a graphite, different form of carbon. Cathode, what is happening here? Reaction. Cation. Cation is which one? Aluminium. So we are taking aluminium, 3 electrons, Al. Anion. So we are not at, don't know how many electrons are involved at anodes. Let's see. And anode. Huh.
Sir, isn't the anode attached to copper clamps dipped in the electrolyte?
Huh. But it is a clamp, but what we are using here is graphite. They dip the graphite rods inside the electrolyte. That is just to hold. Clamp is just like a conductor, just like a, because you have to give electricity to it, na? So it is acting as a conductor, copper one.
Okay, fine.
Yeah. So anode here, which one? OH minus, no? What released? Oxygen gas. So we know OH minus electron, OH. 4. So 4 OH minus 4 electrons. Okay, 2 H2O plus O2. See here 3 electrons. Here 4 electrons. How you make it even? Now I don't want you to confuse. If you're in your school they told something else, fine. But what is the correct way? You have to have same number of electrons at anode and cathode. Okay, if they simply ask you, write the reaction at cathode, you can simply write Al3 plus 3 electrons Al. If they ask you to write both, then you must equal them. See, 3 electrons, 4 electrons. So multiply this by 4, multiply this by 3. So what you will get? 4 Al plus 3 plus 12 electrons give you 4 aluminium. Here, 3 into 4, 12. 12 OH, right? 3 into 2, 6 H2O plus 3 O2. Okay, here minus 12 electrons. Okay, so then the number of electrons are 12 here and 12 here. So how you know it? See, finally what you're doing, Al2O3 you're breaking down into aluminium and oxygen. This is a reaction taking place, right? You balance this, 3 here, 2 here, 2 into 2, 4 here. Are you getting the same 4 Al atoms, right? 3 oxygen atoms. When you take 2 Al2O3, okay. If in your school they told something else, that is also fine, because they know better. I mean correction, and but this is also not wrong. Match the column for, they have given here explanation with some uses. Then you have to match it. First one, who will tell me? Anybody can tell. Alloy of copper in zinc.
Brass.
Brass. Right. Stronger than aluminium, lighter in weight. Aluminium, if it comes, so you have only one, duralumin. Huh? Lustrous, hard corrosion, surgical instruments.
Stainless steel.
Stainless steel.
Stainless steel.
Tin lowers the melting point of the alloy.
Solder.
Solder.
Name itself tells soldering purpose means solder. Here, this point you remember. What is the role of tin? It lowers the melting point in solder. Last one is A, B,
Bronze.
C.
C.
Bronze. Okay. In duralumin, aluminium brings lightness. These are some sometimes asked. Magnesium gives you strength for duralumin. Okay. For stainless steel, they have chromium. I think it gives a shine or luster, you can say, to give luster. Hmm. For tin, you have lowers the melting point. In solder, tin lowers melting point. So what are uses of alloying? To modify the properties of the metals. Don't worry about this one. This is actually electro refining of aluminium. We don't have this, sorry. We have this simple one. A negative, negative is cathode, means gas carbon. B is positive, anode. So graphite, B is made up of graphite, A is made up of gas carbon. You can write in the bracket carbon only. Huh? Make will be carbon only. Graphite is also carbon. See, sometimes we don't know which answer they will accept, so we will write both what we know. At which electrode is the aluminum formed? So at A. What are the two aluminum compounds in the electrolyte? C. Why is it necessary electron continuously replaced? This question we did not answer. See, what happens at anode? Oxygen gas is released, right? So anode is graphite. Graphite is carbon. So oxygen gas, it will react. Normally it will not react, but the temperature we are having here is 950 degrees Celsius. Therefore, it will react. Initially it will form carbon monoxide, then it will oxidize to carbon dioxide. Okay, therefore, because it is get oxidized to carbon dioxide by the oxygen gas released at graphite, we have to continuously replace the anode, which is graphite rods. Okay, so these are the things. Last one more thing, practical chemistry. Simple questions will take. Most commonly asked question. This is most time asked. Manganese dioxide, copper 2 oxide using conc HCl. So both are black in color. Both are black in color. This fellow will give you greenish yellow gas. Don't write chlorine gas. Okay, you can write greenish yellow gas, which is chlorine, is released here. Here, no gas is released. Why? Copper oxide is base. Acid base reaction is neutralization. So what you have to write? You have to write the sentences. Manganese dioxide with concentrated HCl gives a greenish yellow gas, which is chlorine. Copper 2 oxide with conc HCl will not give any gas. This is how you distinguish between the two. Okay. Ferrous sulfate, ferric sulfate, to by color of the precipitate only you will tell. Dirty green, ferric, reddish brown. Third one, dilute hydrochloric acid, dilute sulfuric acid, lead nitrate. This one I told you previously. So here you will, both the cases you will get white precipitate, but lead chloride white precipitate is soluble in on heating. Whereas lead sulfate formed will be insoluble on heating. Okay. These are the most commonly asked questions. See, the same one they can just change instead of hydrochloric acid and sulfuric acid. Anions you have to see. They can give you sodium chloride, sodium sulfate. Same thing. Magnesium chloride, magnesium sulfate. Lead nitrate only you can use. Same observations. Okay. Next one. Hydrogen sulfide. Nitric oxide. Nitric oxide you can match with C. Turns reddish brown when it reacts with oxygen. Carbon dioxide you can match with B. Sulfur dioxide you can match with A. Turns acidified potassium dichromate solution. This one. Hydrogen sulfide you will give it to moist lead acetate paper, silvery black. So you have to see what is common. In the first case, anion is common, so don't worry about it. Cations, if it is different, what you have to do? Either NaOH solution or aqueous ammonia solution, you have to think. So directly you can use aqueous ammonia solution. Why? Calcium will not form any precipitate here. Zinc will give you white precipitate. Even you can also use aqueous sodium hydroxide, then you have to write a lot. Both will give you white precipitate, but in excess zinc, white precipitate from zinc will be soluble. Okay. Ammonium sulfate crystals, sodium sulfate crystals. Again, sulfate is common. Here you can add alkali solution, sodium hydroxide. So what happens? And heat. So for ammonium sulfate, though, you will get ammonia gas. So you can write the test for this. Sodium sulfate, though, you will not get any gas, nothing, because cations are same. Magnesium chloride, magnesium nitrate. See again, chloride and nitrate. Previously what I told you, lead nitrate you can use, or even silver nitrate you can use solution. So here you will get white precipitate of what? AgCl. Soluble, this also you have to mention, soluble in ammonia solution. Okay, that's what I'm telling you again and again. Nitrate, no precipitate. Identify the salt, these kind of questions also asked. I think you did not forget about the color of the flame. Sodium, potassium, calcium and copper. Sodium, what is the color? Flame color?
Golden yellow persistent flame.
Yes, golden yellow. Potassium?
Lilac flame, non-persistent.
Calcium?
Brick red flame.
Okay. Copper?
Bluish green.
Bluish green. Chalo. So here, light bluish green color. Salt P. This is not flame. This is salt. On heating, it produces a black residue. Brisk effervescence with dilute HCl and gas evolved turns lime water. So this is obviously no effect.
Copper carbonate.
So light bluish green means usually copper. Black colored substance means copper oxide is black. CO2 gas is coming to copper carbonate. But don't write the formula. If you want to write it in bracket, write the name. Okay, next one. White in color. White means, not copper, not iron. On strong heating, it produces buffalo residue. Buffalo, we know lead monoxide is buffalo, right? Reddish brown gas to NO2 gas. So easily you can guess based on this.
Lead nitrate.
Lead nitrate. Salt R is black in color on reacting. Pungent greenish yellow gas. This one to black in color, which is that MnO2, manganese dioxide. Manganese dioxide you write, or if you want, you can also write manganese 4 oxide. Its IUPAC name is manganese 4 oxide. Last question. This is from your okay. Blue crystalline salt. Again, blue crystalline means so immediately you know what it must be. On heating, it produces a white anhydrous powder. Okay. So what is this? The salt P is actually
No vitriol.
Hydrated copper salt.
hydrated copper sulfate, crystalline substance. Huh? You can also
Sir,
write
we can
because they simply ask
write
name.
solution, right?
What?
So we can also write copper sulfate solution, right?
They
For
ask you
A.
here, name the compound P, means just write the name, don't write the solution.
Okay, sir.
Right? See, because they are given here crystalline salt P. No? Later they are dissolving, but they have asked you to write the name of the compound P. Compound is only substance, not the solution. P is dissolved in water. Zinc is added to one part of the solution and to another part of the solution, barium chloride. Means two test tubes. In that we have this solution. Hydrated copper sulfate, means copper sulfate solution we have in two different test tube. In one we are adding zinc. In another we are adding barium chloride. Okay. Hmm. Mention one observation when zinc is added to the solution of P. What do we observe here?
Sir, a white solid is formed which turns yellow on heating.
Why? No, 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 no. See,
So the blue color of copper sulfate solution will get discharged.
Parth, what we did here, we took the compound, it dissolved in water, right? Then you have a solution here, two test tubes, aqueous solution. Huh? So in that you're adding zinc, means simple displacement reaction takes place.
Sir,
Yeah.
can we just mention a reddish brown deposit of copper? Reddish brown metal
Mention
deposit
one
of copper?
observation. You can, yes.
Yeah.
Reddish brown metal or pink metal deposited. Or you can also write with respect to color of the solution, blue color fades. Isn't it? Why it fading away? Because zinc plus copper sulfate. Displacement reaction we learned. No. Zinc more reactive. Zinc sulfate will displace the copper. So two observations, any one you can write. State the color of the precipitate formed when barium chloride is added to the solution of P. Solution of P is copper sulfate plus barium chloride. What is the color of the precipitate? White. Barium sulfate is formed, no? So they can also ask you to write a balanced equation. So you know how to write. Okay, this is the last one.